Okay, we appear to be live. Let me do the traditional share to Twitter. And a bunch of upgrades have been made. The modem was just restarted. I have knocked the stream speed, or the stream bitrate down just a touch. I have checked speed test a couple times to feel like things are stable. Who knows? The camera should not turn off now. It's been tested. The audio's a little different, but you probably won't notice much of a difference. But anyway, let's share this bad boy. Don't look at my personal stuff. Twatted. And let's also drop that on the Discord, because why not? All right. So, good morning again, Wereworm. Hey, Trey. You can't see my screen. I assume you wouldn't be able to. You should be seeing the NES garbage right now. I'm looking at the live stream in YouTube right now, and that's what I see. So let me know if for some reason you can't see the NES garbage. Okay, so recovering from last time, I've done a little bit of research. Turns out, one of the big things is... So I was looking at this, because at some point, I don't know if it was leaked, I think it was leaked, but the Microsoft Basic source that we have been looking at is like the original source for the PDP-10 Macro 10 assembler, which we don't have that assembler. And it's a hack on the Macro 10 assembler, which is actually an assembler for PDP-10 code that, oh no, good old what's his name, the not Bill Gates. Paul Allen, the good one. Not to completely throw Bill Gates under the bus. I guess he's had a bit of a turnaround, but Paul Allen is a sweet man. Was a sweet man. God rest his soul. Anyway, whole bunch of rambling. Turns out, I was looking at that, and I was looking at this. Oh, now you can say you can't see my screen. There we go. Sorry. So, I was looking at the original source code. We were looking at this page. The BMAU stuff, he's talking about how there's a version, the version that he was using was written for the CA65 assembler, which is the one we're going to try and use here, which I also did a touch more research on. I did look up the minimal NES example for CA65, and I think we can work with it. But, yeah, so that's confusing, because yesterday I was saying maybe this is the CA65 one, but it's clearly not. It is clearly not. I forgot. This was itching something properly in my brain, because this is what I was thinking of. Some dude, Michael Steele, back in 2008, put in a ton of work disassembling, I almost said AppleSoft Basic, but that was the one for the Apple. All the versions of Microsoft Basic for various, the Commodore Basic, the AppleSoft Basic, the Basic for the Kim 1, and disassembling them, cleaning them up, and also comparing the differences so that he can put in compile time switches to be able to actually compile the different versions from his disassembled source. So this is what you really want to use, and it's already in CA65 format, so this should be more usable. And it's very interesting because I was reading some of this, actual original Microsoft source, and it's funny because, this guy had to go through all the trouble of comparing the versions to figure out what the compile time switches were adding and removing, and you can see that in the Microsoft source, so that's kind of fun. You can see the actual, directives and whatnot, and I am sure he got it right. So, direction for today, again, at the end of the day, I want to hope that this stream keeps up and doesn't drop. My fingers are crossed. And then we want to sit here and work until I can print a string to the stupid screen, which is going to involve learning a lot of stuff. So follow along with me, won't you? Because the first thing we need to deal with is learning how to use CA65, which I was trying to do and failing to do last time, because it's a bit of a complicated beast. No goats have been sacrificed to the internet gods yet. Hello, Dirt Piper. Good to see you all. So, I like how this is a minimal example. And I was warned about this the other day, but let's see. So the actual source is this example.s, and it's 785 lines long, but it's pretty involved. I don't want to. This is doing a lot. This is not. I don't need to reproduce any of this code, and because this is producing an actual emulator compatible ROM. It's even more complicated because, let's see. So this example.cfg is basically the part that tells the linker where all of the segments that you've specified in the assembly are. And I don't need all, because they have the header, which again is just for ROMs for emulators. It's not actually on a card. And for my uses, So I could make a ROM, but it would be kind of funky because I'd need to... I guess I could take the character ROM from Super Mario Bros. 3 and append it to the end of this. It's an option. And then make sure my program ROM is the size of the Super Mario Bros. 3 program ROM, and make sure my header is exactly the same as the Super Mario 3 ROM that I have. That could work for running it in the emulator, but I don't know, because all I really want to do is assemble a program ROM that is the size of the EEPROM I'm using, and that's all I want to do. So I think I can simplify this a lot. Also, they're doing a lot of stuff. So you can see there's entries for the 0-page object attribute memory, which is sprite attributes in the video card, whatever, the PPU, and RAM addresses for other, variables and what have you. And I don't think I'm going to go to the trouble. Like, I'm just going to manually define locations. I'm not going to use all this. And mostly you have this stuff because CA65 works with CC65 as a whole package, and CC65 is a C compiler, which can really benefit from having all of these areas. But if I'm writing assembly, I don't know. I think I'm just going to define a program area, and I'm going to define a code area, and the rest of this I am just going to basically ignore. So I guess let me pull this project. Let's see. And I'm going to put it, because I don't want to directly use this source. I just want to pull stuff out of it, or use it as reference, really. So let's make a code directory, because on this computer I don't have one yet. Oh, apparently I do. Never mind. Oh, apparently I was doing high Pico stuff on here. Well, anyway. Git clone this guy. I am losing my mind. Code. Copy. Nope, that didn't work. Git is not recognized? What? What? How on earth do I not have Git installed on this machine? Well, let's fix that. Wow. No Git? Really? Nope. Okay. Git clone Git. Trey Dempsey says, it's not minimal. I did homework. CA65 needs a linker script and several segments. I'm hoping, fingers crossed, that there are some segments it wants by default. I'm hoping I can just throw it in one big code segment and make that code segment go from 00 to FFFFF. But we'll see. We'll see. I hate linkers. I hate them so much. I don't know why. I feel like they're unnecessary evil, but I don't know. Every time I've worked with linkers, they just feel like black magic. I mean, obviously, like, I know exactly how they work, and they're very straightforward. They just take your chunks of code and put them at the appropriate places in memory, but I don't know. It's just a me thing. I hate them so much. Derek Koingsberg. Hey, you made it! Nice! I used CA65 for a project once using an NES CPU, but thankfully it wasn't a complete NES, so I didn't need to make all the extraneous bits happy. I would be interested to know what more... I'd be interested to know more about that, because I'm not sure what you mean. Like, I understand what you mean, but I'm curious how it was just an NES CPU and not the other NES bits. Yes. Okay, let's install this BS. Sure, whatever. All the defaults. You would think at this point that installing Visual Studio Code would install Git by default, because it has built-in Git tools, so... I don't know. Something is probably stupid and wrong on this computer, and I'm just going to ignore it. Trey Dempsey says, not using Linux, for shame. I know. It's that... I was talking about this a while back, but I have Windows on... I actually had Linux installed on here when I first set up this machine, but it's just so much easier to have a relatively no-hassle experience with Windows, especially with, like, OBS streaming. I mean, OBS works great on Windows, great on Linux, but, like, with all these different various cheapo USB devices that I'm using for input, I just don't want to futz with them being supported or not supported. Okay. So we should finally actually have Git. Let's see if it's actually in our path now. And I tried to set this up as a Visual Studio developer shell ages ago, and it didn't tick. So that's why that. Okay, let's try that again. Yay, it did it. So, let me start by... Wait. Oh, shit. Shit. Didn't mean to do that in my... It's just a PC source folder. Whoops. What is NES? Blah, blah, blah. Sure. Yeah. Let's do that in that code folder that I made. Oh, because I have it in documents, like a moron. Okay. Let us open... Because I think really all I need is my source and a linker config. If I looked at the build batch file correctly when I was looking at it. So, yes. Let's just... I'm going to strip out as much as I can and see if it works. Code. This guy. Okay, so let me start by just pulling the... Oh my god, I have... Don't hide extensions. I'll deal with this later. Hate. Okay, it should be this one. I I hate that Windows defaults to hide known file extensions. It's the stupidest fucking feature they ever added. I realize it's been there for ages and ages now, but I still hate it. Do the crickets have a party, or is your computer fan broken? It's crickets. I can't really hear them because I'm wearing the headphones, but I know they're out. Okay. Forget that. Forget all that. Forget that. Forget the header. We're just going to use program. It's going to be a flat address space. It's going to be... I mean... would the size be this? Maybe? Fill, yes, I guess. And fill with 0, and I don't really know how that works, so we're just going to use the defaults. And then delete this, delete this, delete this, delete this, and then this, and this, and this. And we're just going to have the code segment, which is in the program memory, and it's going to also start at 0. And hopefully that roughly works. And then let us look at their build script. And let me actually copy this into a local file because I just edited the one that's in the repo. New file. Link.cfg, let's call it that. Whoops. There we go. And delete the crap out of that. Yes, I do. File. Open file. Let's look at the build script again. Compile example. There we go. So they got a bunch of stuff going on here, but basically they call CA65 to output this example.o, which is the object file output of assembly. And they use LD65. The output is whatever. In our case, it's just going to be like rom.bin. You use -C, pass it your linker thing, and then these are optional as far as I can tell, all of that stuff. So I think, well, I guess I'll make my own script. I mean, why not? Do I have make on this machine? No, of course not. So let's just make a PowerShell script, because I'm gross. I don't know what I just did, but let's try that again. And I'm just going to copy the bits I like. Okay, that didn't take. And, oh, that was the link. Okay, and I'm going to add CA65 and LD65 to my path because I must. I don't need debugger symbols because I'm a madman. Let's call this, I don't know, basic.bin. And this will be link.cfg. And this is going to be, I guess, let's just call it main. Or, heck, let's just call it, because I really don't intend to use more than one file here. Yes. And I like calling it ASM, personally. That's pretty arbitrary. Okay, so let's rename this to basic.asm. That also didn't take. What am I doing here? Basic. There we go. And now we're going to have to totally fix this up, but the fun thing is, based on what I saw in other code examples, I think my camera just made a noise. Oh, I think it was turning a live view on and off. That's the... I bought a thing to make it keep resetting itself so that I don't have to keep doing it. So hopefully that'll be a slightly better experience. So let's look at their code and how they define segments, because I think you can just segment an org, and I can use that to improve my experience a little bit. So like I should just be able to like not bother with this, call this segment code, and you can refer to the same segment multiple times, and your org will tell it where in that memory space it's actually going to be assembled, and then that fill setting, this guy, fill yes and fill val is zeros, should fill up any space that doesn't have actual assembled code into it. So that's a nice thing that I should be able to leverage for myself, at least. But yeah, let's look at some of that example code to make sure that that is correct, and I am understanding that correct. Example.s, because I am fairly certain in here. Okay, yeah, it's just dot segment in the name of the segment. Cool. That, like, the code segment gets referred to several times. Cock, yes. Or it only gets referred to once. Well, I think something got referred to multiple times. Wait. Yeah, my search is just dumb, because there's another code segment right here. So, yeah, I think that's legal. Let me read chat and see if they think anything I'm doing is dumb yet. Lettuce C is definitely a t-shirt idea. This is still child's play compared to GCC linker scripts. I'm always banging my head against the wall when trying to make those do what I want. Trust me, I know. I first encountered linker scripts when I was working on my little crappy homebrew operating system, which is on my GitHub page if you want to look at it. The source is terribly organized and it's not great. But yeah, I didn't really get linking and whatnot when I was writing that when I was a teenager, and at one point I finally learned about linker scripts. It was like, oh, I can do a lot of the hard work like in the linker script, and I thought that that would be a nice solution, and then it ended up just being horribly painful. So yeah, there are people who, I'm sure that seems very straightforward too, because they've spent a lot of time doing it, but like, who spends that much time working with linker scripts? Yeah, Trade MC says, there's some definite positives to using CA65, even though setup is a pain. And I can definitely see that. Like, if you were working on a really big project, which we'll have to see, because the basic project is fairly big. I actually do forget, I was saying I wanted to keep everything in one file, but I'm still thinking about the actual Microsoft source for basic, which is one file. That guy's reverse engineered version is split up into a bunch of files, I believe, so yeah. We're gonna have to figure that out and possibly move a bunch of segments around in that code, but we'll just see when we get there. For now, I think I basically just wanted to check the segment code thing, and yeah, let's just go for it. Send it. So close this, don't save, and let's look at our code here. So segment will be code, because that's my only segment. Org at E1000, which is where I'm starting the code on my EEPROM. All of my code, and then I really shouldn't need this anymore, because I should, again, just be able to do org FFFA. Interrupt vectors. Why am I writing everything in bold? In uppercase? I don't know. Don't worry about it. Alright, let's go back to this actual directory. What is this? It's just a PC. NES. Source. And, of course, CA65 is not in my path. Even though... oh my god. It's escaping me. My profile. Even though I set it right here in my profile, and I guarantee you, if I copy this and paste it and run it, I have no idea. Like, my profile just isn't being executed for some reason. Oh, you know what? It's probably because of all that crap, because this is all fudged up, because I tried to set it up as a Visual Studio developer console, and that's all messed up. So it's probably that. That's screwing up my path. That would explain it. Anyway, let's just try running this link script, or this build script. I guess I should have named that build up PS1. Whatever, we'll deal with it. Oh, I haven't even enabled scripts on the system yet. PowerShell. Yes. Allow it. No, disallow it. And now I have to remember set execution policy. Unrestricted. Yeah. Let it do whatever it wants. Okay, it did something. Let's see how big this is. Basic.bin is 64K. I think I may have gotten away with it, people. I almost opened it in the XG Pro thing, but I'm going to be smart, and I'm going to open an XVI32 in case there's things I actually want to do with it once I have it open. Source. That looks dang promising. Oh, wait, no. Actually, that's at 0. Like, it looks like that org didn't take. Yeah, and that ain't right, because my reset vector isn't at the end. So it looks like it kind of jammed it all together at the top. Damn. Damn, damn, damn. Okay, well, let me see if I can use those repeat statements. Because I just want to do this in the dumbest way possible. And I don't mean dumb in my normal, like, do it in a silly way. I just mean, like, do it in the most simple way that I possibly can. Okay, there's that one. There's that one. And again, when I actually start pulling in basic code, it's going to go back to being complicated again. I mean, of course, that's like the hard part. Right now, I'm just doing very, very easy stuff. So, okay. So I've got my repeat stuff in here, which I don't even know if that would work the way I think it does, but here we go. Line 86, constant expression expected. Really? You can't math in here? Are you for real? Probably because they expect you to use the linker to do this stuff instead of jamming bytes in there. Balls. There's some definite Trey Dempsey says, there's some definite positives to using CA65. Oh, I already read that. Dirt Piper says, he can't keep getting away with it. Can't he? Okay. Balls. Fine, I'll write segments. Segment, let's call this code main. Delete this. We'll just define that code main starts at E1000. Okay, and we will define this as its own segment called vectors. Exactly what it was called in the other link configuration. Okay. But we should be able to put them all in the same program memory space. I'd better at least be able to do that. Code main, is that what I called it? And that's going to start at E1000. And vectors, is that what I named it? Vectors? Vectors, no. Yes, but this one we want to start at FFFA. Okay, try it. Yes, yes. It didn't throw me any errors, which probably means it's still bunged up in some other way. XVI 32. Basic.bin. Okay, we got lots of zeros. Lots and lots of zeros. Go to E1000. AAA. It is very annoying that this width is not set to a multiple of 16 or 8 bytes, but whatever. This looks like it's getting somewhere. Yeah, I think we did it. Okay, so now we have code that actually looks like the stuff that was coming out of the online assembler. We've gotten this far. It only took us half an hour. And so far, it seems the stream has been pretty stable. Let me know if, like, the resolution is too low and the screen isn't very readable, anything like that. Okay, I am going to take this moment now that we have a CA65 program building, and I think I'm kind of getting it, to finally crack this dang beer that I've had sitting here. Alright, and let us review the code. Because now I actually need to start writing code. So, we clear some stuff so that the CPU isn't constantly interrupted by other hardware. We initialize the PPU state, which I think this is good enough. We are also setting scroll here. So this is setting the X scroll to 0. This is setting the Y scroll to some weird negative value, which technically isn't supported. And actually, the first change I think I'm going to make is I'm going to initialize the scroll on both of them to 0. And the reason I was doing that negative scroll was because my A, that is in the top left corner, is falling off the screen. And so I think I should just put it on the second line already, because I don't want to have to do weird scrolling when I actually get this, like, more properly working. Yes, so where am I actually placing that A? Oh, I think this is all doing it. So we have, back to actually reading the code. So we do the basic PPU, setting up PPU registers. Then we write some stuff into the palette addresses of video memory. So this sets our background color. Color 0 is always the background color for all palettes. Then palette 0, color 1, palette 0, color 2, palette 0, color 3. And then this is basically what I managed to do last time, was clear out the attribute memory, which controls what areas of the screen have which palette attached to them, so that they're all set to 0. And that seemed to work. We still have garbage for characters on most of the screen, except where I'm writing that A, but I believe that is here, which we haven't looked at this in a hot minute. So, this is selecting register 0 of the MMU, which is, of the MMC3, the chip on the card that controls the bank mapping. and we're setting register 0, which is, I guess, the first character window for mapping. And then we are writing 5E to the kind of like the which bank to map into that window, which is where our text was, and 8001 is the data register for setting the value. So you set what value you want to write here, and then you set the value that you want to set that bank to here. Then, subsequently, yes, this is the part that is actually set the, let me write what I want to do here. Set the first character of the second row to the A tile. And so this goes through that register window into VRAM memory, so we write to address 2000, which is the beginning of the first screen, as it were. There's a proper technical name for that, but whatever. And then 30 is the tile number for the A tile, and we write that to that first spot. So I need to increase that by, how many characters are there in a row? It's like 32 or something? No, that seems too high. Let's look at the documentation. Name tables. "30 rows of 32 tiles each," yes. So I just need to add 32, which is hex 20, to my address, so it would be written to 2020, I believe. Alright, so with that change, let's just go ahead and build this again and test it out. And basic.bin, load to 1000, cool. Looks kosher to me. Pop this bad boy up. This has been running for a while, so since I have it up anyway, as we saw at the top of the stream, that's what we currently have after my recent palette change. In the top left corner you can just barely see what I do believe is our A, and hopefully that should be down one row. Like, our scrolling is going to get reset. It's not going to be down as far, but hopefully by putting it on the second row we can see it. We'll see. This is all experimentation. Anyway. Boop. And then, as I said last time, let me do this, and then I will actually write that little script to inject my code into the Super Mario Bros. 3 ROM image, which should be pretty trivial, and then I can run it in the emulator. Again, I could probably do that with CA65's linker stuff, like just link in, because I already have a separated out copy of the Super Mario Bros. 3 character ROM. So, again, theoretically, I could assemble my own program ROM, because I'm not using any of the code from the Super Mario Bros. 3 cartridge. I'm just stuck with the character ROM. And then, you know, attach a correct header, which wouldn't be hard to get right, because I can just look at the header that's actually in the frickin' existing ROM. Maybe. And then I could write like two different build scripts, one for building the image to put on this EEPROM, and one for making a ROM. The more I talk about it, the more that really sounds like the way to go. But I really want to write a little script. Will you be streaming manually setting the pixels for all the characters? So that's the thing, Dirt Piper, is just out of sheer bloody-mindedness, and because it's stupid, and this time I do mean stupid as in, like, it's actually dumb in a silly way. Since I have the Super Mario Bros. 3 character ROM on this cartridge, like, I could rip it out, I could put my own replacement in there just like I did for the program ROM, but, like, I think we probably have enough characters in there, and I'm just gonna use them. The fun thing is that will make that more silly too, is I was thinking about this earlier, and like, okay, so obviously we have all of the Latin letters. We might have some punctuation. I could believe that somewhere in this ROM there's, you know, maybe exclamation points and periods. There's probably a good set of numbers. There's gotta be. I mean, there's numbers in the UI. I've seen spots where there are like limited numbers for certain screens where they didn't need all the numbers, so they just have a bank that has some numbers in there. But surely there's a good set of numbers somewhere in there. But then, like, when you get into the characters that are used for the operators, you know, greater than, less than, equals even, I feel like the odds are pretty low that those are going to be in this character ROM somewhere. So, what if we just used some Super Mario Brothers 3 characters when we need those things? And I think that could be quite silly. Almost like programming with emojis. Yeah, no code page 437. I mean, that could be fun too, honestly. Rewriting our own character ROM that has, like, block drawing characters and stuff in it, but, let's start here. I don't want to... It was already so much of a pain in the ass to yank out the program ROM. Yeah, let me read. Trey Dempsey says, no buffering here, much less annoying. Excellent. You could hide the left sidebar for more space. Are you talking in VS Code? Yeah, I can... Yeah, probably. Maybe I will. Will you be streaming manual setting? Yeah, that was what I was just talking about. Using an EEPROM emulator makes this less annoying. Yeah, because Derek, you were saying you hadn't made it to the streams before, and I have mentioned before, so this project, this was a Genesis cart that I did quite a while back, and it is 2 of those chips are ROM and 2 of them are RAM, and you can remap them using a little register that's in this logic, and that made this semi-useful because then you can, there's kind of a monitor in here that lets you stream, you know, code content into the RAM on this card and then execute from it. So, yeah, but I'm doing a much more hacky thing because Nintendo carts are weird. Yeah, and don't forget all the emojis we need these days. Yeah, we're not going to do code page 437, but I am going to implement the entire Unicode emoji character set. How about a ZIF socket for the chip adapter? I actually do have another ZIF socket around, but I wonder if I could jam the ZIF socket. I mean, like, honestly, I could replace, because this stack is a socket on the board so that I can throw the actual program ROM back into here. Then 2 sockets where one provides the rewiring and remapping of the couple pins that I need to remap to put my EEPROM into this socket. So theoretically, I could replace the top socket with the other ZIF socket that I have, or I could just jam a ZIF socket into the top guy there. Actually, honestly, one second, because I think I know exactly where that ZIF socket is, and the legs are pretty chonky on it. I feel like they'd make good contact, so I wonder if just plugging that in would work well enough that I can stop taking this cartridge in and out. You have made me think. Damn it. Never mind, I lied. I have no idea where that ZIF socket is, apparently. I have a box that I put hardware stuff in that's supposed to be like connectors and switches and, you know, non-chip or component parts, and it's not in there, so, Spooky. Ah, well. Did I program this? Can't hurt to do it again. Turn the NES into an IBM PC clone. Well, I do like the, Come on. Sometimes it just doesn't take. I think this chip is potentially a little marginal. There's the guy who I'm forgetting his name. I was pointed to him by a work friend because he does really dumb projects, and he was the one who did put a Raspberry Pi of some sort into an NES cartridge to inject stuff into the frame buffer in real time, and wrote a SNES emulator that interfaced with that, so he was playing SNES games on NES hardware. Yes, I should do the same thing for the IBM PC is the point there. Okay. So, this should have the same kind of garbledy, orangey look. Yes! Yes. Yes, Narayan, Sucker Punch. Yep, that's the one, Dirt Piper. Reverse emulating the NES to give it superpowers. Great project. What is Sigbovic? That sounds interesting. Let's go to the right screen before I get too distracted. I have no idea what I'm looking at. The scroll is indeed different. Okay, what on earth is with this scroll in this console? Because I wrote all of that attribute memory, and you see that gray area at the bottom, right? I feel like that leads me to believe that that is the next like map down, because there are up to, especially we're using the Super Mario 3 cartridge, so I think it is using the on-cart VRAM to allow it to have 4 screens. I don't know, but you can have up to 4, or at least 2 side by side or on top of each other. So are we seeing the next map down there? Or have I just not set all of the attributes? It's a mystery. But... oh, wait, I think I do see the A. And I think it's just scrolled up just enough that we're seeing... well, let me scroll it down one more position. Or let me move it down one more line. So let's put it at... right now we put it at 2020. Let's move it down another line. 2040. 2040. And then let's build this injection script already. Because since I don't know where that ZIF socket is, this part is becoming real untenable. And wastes a lot of precious viewer time. Though it gets my watch hours up, so there you go. I might be able to monetize soon and make a whole $6 a week. Might be cool. Okay. Load. Yes. 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 Program. Yes, verify. Okay, good. Thank you. This will be the time it breaks. We should just, like, start a Deadpool for this cart based on number of cycles. And any change? No, that looks exactly the same. That didn't change jack. So I clearly don't know what I'm doing. Time to debug it in the time to debug it in the emulator. Wereworm says it's an MIF socket, maximum insertion force. Correct. Did you set up the PPU and wait 3 V blanks? That's a thing, isn't it? I saw something about waiting V blanks for doing stuff. So... No, I didn't do that. Fine. Let's set up a V blank interrupt. Let's learn about how to do that. Though that said, I'm clearly writing to the attribute memory. I'm writing something, and I'm writing to the palette memory, so... It seems to kind of work. Whatever. I don't even know I'm taking this chip out. We're moving all into cyberspace for a minute. We're not going to use the actual machine for a little bit. Let me... I'm going to make a subdirectory here. Did I make one when you guys weren't looking? No. Okay. I'm going to make a tools directory. And I'm going to injector. Yeah, there we go. And I'm going to write this in .NET because that is the thing I am most familiar with. .NET new console. All right. Let us. Because what I'm going to do here is just take the Super Mario Brothers 3 console, or binary, and inject my code into it. So, let me see. I use this for a living, and I'm not, I mean, I do this for a living, and I'm already feeling lost. Let's read some chat. Not to be confused with the LIF sockets 386 and 486 CPUs went in, where I'm not even sure if it's possible to insert a chip without bending or breaking pins. What's LIF? Or maybe I just had bad luck the 1 or 2 times that I tried. I mean, I know... I mean, this was when I was young, so I was doing even dumber stuff than I'm doing now, but, like, trying to get 386s and 486s out of the, like, just regular machine socket, and, you know, machine pin, pin grid array sockets, so easy to fuck those up. Wareroom says, that's why they switched, and now you bend the pins on the motherboard socket. Problem solved. You get it. Yeah, Trade MC says, there was a pry tool for 386, 486 CPUs that helped remove them. There was. I hear it may not have particularly helped. Low insertion force. That's what I was thinking, probably. Turp Piper says, just use a comically small toilet plunger to yank the chips out. I can't argue with that. Alright, anyway. I'm getting confused because... I don't often write, oh, I forget what the term for this is, but it's the new C# style where you can write top-level statements without, like, writing a namespace and a static class and stuff. And I want to do using var rom stream equals file dot open. Let's see if I can get some IntelliSense if I actually open this project in its own folder. Source tools. Yes. Injector. And I probably don't have any C# extensions installed. So let's do that. Also probably why I don't have IntelliSense. But we'll keep going, because I work in Visual Studio all day, so if I don't have IntelliSense, you know, I'm just useless. Let's just... I could supply args, but right now I'm just going to drop it in the same folder as the executable. Or, I don't know. We'll work backwards from here. And of course, I already don't know what the name for the constants for read binary or write binary mode is. Okay, cool. Trouble loading. Sure. OmniSharp doesn't like something. Can't access the file because it's open in another process? Is it because I have it open over here? Doesn't look like it. Here, let me just restart everything. That is always the best solution. Okay, work better now. Give me IntelliSense. Hey, the highlighting makes more sense now. You can do it. Yes. smb3.rom. Because who wants to look up documentation, right? File mode dot what are my options? Open? Guess so. Actually, I think what I want to do is I'm going to be super lazy because I could take a file and update the contents of it, but let's just copy it to a new file. So other open options here too. Yeah, open read. That's what I want. And now I can use this and read this in chunks. I mean, it's pretty small, so let's just read the whole top chunk, and then, yeah, let's start with var header data equals new byte, and I know it's 16 bytes long. And we shall read that, and yeah, I think I'll just read the header data, copy it to the output, write 64K of zeros, then write 64, actually, yeah. I'll also need to provide our binary as an input. So read 64K of, oh, I was saying I was going to totally do this as a CA65 script, wasn't I? Or a linker setup. No, never mind, I'm already writing this. Too late. So let's rom stream dot read it into header data, and 0, 16, done. There is, I really should have just done copy to output. Oh well. Let us also use using var. Let's rename this in rom stream, out rom stream, open write basic dot rom, and also using var bin stream file dot open read, and that's going to be our basic dot bin. And okay, back to what we were doing. So this is in rom stream now, and let us. So we've read the header data. Now let's do rom stream. Oh, also let's make this Do I not get file options here? Oh, I don't. Okay, so it's going to create a new file by default. Good. If it already exists. So outstream write header data 0, 16. Okay. Header data. Copied over. Done. So copy over ROM header. Then let us there's probably a good way to just write a ton of zeros, but I'm going to do it this way. Write 64K of zeros. That is not how that works. Let's do it this way. And can you do that? No, this is not like C. An array initializer of that length is expected. Super cool. Shoot, there's definitely a way to do that. I mean, well, an array of byte in C#, because Z# actually has default values, and the default value for a byte is almost certainly 0. Hell, let's just run up to this point. I'm going to have to copy some files over. And let me make sure that that gets initialized 2 zeros. So let's copy our basic.bin. And our Super Mario Bros. 3 ROM, which is somewhere, probably still in my download folder. I'm not even going to look at chat because I'm afraid of what you might be telling me about my foolishness. Super Mario Bros. 3 NES.bin, I think that's the one. So I shall copy it to Documents, it's just a PC, NES, source, tools, injector, and rename it SMB3. Nope. Nope. Rename SMB3.ROM. And hopefully that should be all I need, and hopefully it will. The working directory will be this folder. We will see. Yeah, let me just do out rom stream dot write zeros, and I guess my offset is 16. Oh no, that's the offset in the array. So 0. Is there an overload that doesn't need? Oh, I can also use a span. Well, too late. Our length is 64 by 10, 24. Okay, then I'm just going to set a breakpoint here and run it. And make sure that that zeros thing is, in fact, all zeros when I make that new array. I should know. Yay! My intuition was correct. And I also could have just, like, made a buffer of 1024 and written it several times. Or there's probably a command for just, like, write this pattern repeatedly, but we're just making it work. Ooh, let me double check some stuff in chat. Derek says, I probably just didn't have the right tool, and getting those AT motherboards onto a table to do it right was way too difficult. Understandable. Derek says, I still remember back when .NET was just a Microsoft marketing buzzword and nobody could actually explain what it was. Not even with an hour-long presentation. I mean, it's a JVM, but by Microsoft. Oh yeah, Dirt Piper, it's JVM for Microsoft. .NET is I mean, it's cool. I've gotten more into it because it's become my career the last few years, and it's neat. Especially the way that it's, you know, become a little more open and will run on just about anything these days. And I find C# to be a really ergonomic language, even if I suck at it, which is funny because I am a team lead on a .NET team. So, and Trey says, yeah, it was buzzwang for a while, but the CLR is pretty cool. I agree, and the CLR is the part that is the JVM, but Microsoft. Okay, so that rates our zeros, and I looked at chat and nobody is calling me an idiot yet, so I'm okay with that. Anyway, that theory is correct. So now we've written 64K of zeros. Let us now write the content of our assembled binary, and we shall write that from. You know what? Let's be really clean here, and we can actually in romstream.close. Yeah, let's clean that bad boy up. We don't need that anymore. Oh wait, no, we do for the character ROM. Damn. Okay, var our I guess var bin content. Another 64K buffer because it's 2022 and what even is memory, who cares? And we will write, first we will read bin stream. Yeah, people who are better at on-the-fly.net than me, I'm sure there is a version of copy stream that actually allows you to specify how many bytes to copy, but bin content copy offset of 0, copy 64K or 64 times a K of data into that array, and then subsequently copy that into romstream.write bin content. Again, 0, 64 times 10, 24. And, oh, wait, no, actually, it's more than that. This is a 256K ROM. So let us actually do this a few times. Let's write this 3 times, because we actually need 256K of buffer. That's right. That's what I wanted. Well, that is also what I wanted. R equals 0, I is less than 3, I plus plus. There we go. Now I'll just write our 64K of zeros 3 times, and I think we're good there. Then we write our binary content, and then I believe we can just write our, here, let's be clean, bin stream. We're done with it. Let's close it, even though it doesn't really matter at all. And finally, write the CHR content of the SMB3 ROM. And first, we're going to need to skip that 256K of data that we didn't get from the Super Mario Bros. 3 ROM, so we're going to have to fast forward that. What's the best way to do that? In ROM stream dot, can we just seek it ahead? Yes, we can. Yeah, so we should just be able to offset by 256K and seek origin current. That should do it. Then, let's just make a big buffer for CHR content, and I think that is 128. still have the Super Mario Brothers 3 stuff up? No, I don't. SMB Super Mario Bros. 3. Oh wait, you know what? I'm being silly. I have it right on my drive. It is in my downloads. Because I split those files, so I can just look at them. Yes, the CHR bin is 128 kilobytes, just as I suspected. So let's make a new big fat buffer of that big. 128 times 1024. And then we seek past the program ROM in the ROM. Then let's in ROM stream dot read into this char content thing that we made, and offset 0. Count is 128 times 1024. And then subsequently copy that over to our out ROM stream. Char content, offset 0, 128 times 1024, and close everything, even though the operating system is going to do it for us anyway. Actually, the garbage collector will probably do it first. So we can close out ROM stream dot close and in ROM stream dot close, and that should do it. Let's see. Nice. I really need to turn off that developer PowerShell crap. .NET run. Let's just go for it. Did it work? Did it not work? Let's see. Well, it made a file called basic.rom. Let's try opening that in the emulator. File. Open. NES. Source. Tools. Injector. Probably should have named it NES. Whoops. Basic.rom. Unknown ROM file format. Sick. I must have messed that up real bad. Tools. Injector. Basic.rom. Is it just... What if I just rename it .NES? Can it be that simple? Because that looked like a semi-reasonable header. Why did I close FCUX? I don't really know. I think I just opened some search results for something. That's not what I wanted. Open. Basic.NES. Yeah, it still says unknown ROM file format. Qua? File. Open. I'm going to open both the basic.NES that we were just looking at, and open a new window from here. I don't know. And I'm just going to compare them with each other to see if anything looks obviously weird. smb3.rom. So the first 16 look okay-ish. Let's see. Yep, up to ODOEOF07, ODOEOF07. And then this is presumably where the actual code starts, so is the header bigger than I thought it was? I don't think so. I think it's just 16 bytes. Are they the same size? Am I not copying enough stuff? No, this one is longer. Interesting. It appears to be 16 bytes longer. Really? Yeah, because this 1F, 7F, like these look the same, except that this has an extra, fascinating. Okay, let's do this in the dumbest possible way. And I'm just gonna subtract 16 bytes from this. Don't tell anyone. Come on, bro. Let's go ahead and reload this, I guess, for starters. Okay, so of course that would look exactly the same. Oh, you know what, actually... Shit, man, I don't know. Because... Let me read chat in a second here. Even if it was that I need to subtract that 16 bytes for the header from the program ROM space, like, how would this know the difference? Let me read some chat. Derek says, I did C# at 2 points in my career, once in the C# 2.0 days, where I got pretty good at it, and again a few years ago, where all that link reactive nonsense completely confused me. Yeah, it's like a completely new language these days. I like the new stuff, but I can see if you... It's like the old one is Java, and the new one is, like, Scala or something insane. It's really a lot different. Is this the famous off by 16 error? What is the famous off by 16 error? These files should look almost exactly the same now, except for the fact that my data in the program ROM area is slightly different. But that sounds promising. Wareworm says, what is the point of the script? Just to concatenate two files? Basically, yeah. Narion says, I guess to reuse header and char from Super Mario Bros. 3 instead of creating one from scratch. Yep. Yeah, Trey Dempsey says, I thought it was for merging his code with the SMB3 for use in the EMU. You are all right. This would be easy in Emacs. Problem is you would need 5 hands to input all the control key combinations. Someday I want to learn Emacs just because. Control Meta AX Shift Autopilot. Yeah, Wareworm figured it out eventually. Oh, it's for loading into the emulator. Yep. Trey Dempsey says, linker script. You're right, Trey. You're right. God damn it, Trey. I hate when you're right. Okay, let me poke at this for just a minute more and reload this and see if it still looks weird. And maybe look at what this famous off by 16 error is, because, I mean, that sounds very promising. But, like, no, this still has an extra 16 bytes at the end. What did I fuck up there? Did I not save my file before I ran it? Let me see. Let's not close that this time. Okay, so for starters, I think I actually need to take that out of the program ROM. Program ROM space. I think. Maybe. No, I'm gonna keep doing what I was doing here. Let's just run this again and make sure I'm not crazy. Like, maybe it was just something silly, like I did not save my changes before. Oh, wait, also. No, this should be fine. That should be fine. That should be fine, I think. Anyway, let's double check. Apologies, it's my first time NES ROM hacking. hacking Hoodis. What the hell? It's still writing, even though I am subtracting 16 from this. What gives? What actually gives? Linker script. Sunk cost fallacy. I'm not going to keep pushing at this. Let's look at how to include binary files. Just write the header manually. We'll include that header section. Okay. Let's open my regular source folder. Open just ignore this for a second. Pretend that didn't happen. We're going to call this headers. Yes, this is going to be actually weird and different because let's look back at what their linker script was, because theirs is known working. So mine should be very similar. Example config, yes. Oh, and I edited it. That's right. That's fun. Okay. Okay. I'm so frustrated. What if we just make sure this part isn't crazy and lop off the last little bit here? Do you think that's a good idea? He doesn't care. Delete from cursor. Yes. Okay. Let's just save this and see if it loads. Still says unknown ROM file format. That is fascinating, because there's like nothing that says what this is besides the header. I saved this, right? Yes? This has become quite the journey. Let's just make sure it's not cached for some reason. I don't know why FCEUX would do that, but... that is really interesting. NES off by 16 error. Okay, I'm not going to find that very quickly. I'm still fascinated that my script is just apparently not changing the amount of data that it's writing to this file for some bizarre reason. And that FCEUX still doesn't, even after I truncated this, doesn't recognize the thing. Let me make sure like the original ROM is fine. It should be. Aha! Oh ho! There's your issue. Yeah, it's time for you to go down. I wonder, because the original one was named Bin. Does it care about that? Fascinating. Okay. Interesting. Something is deeply strange. How do I not sort these? I hate Explorer. I hate it so much. It is such a pile of garbage. Well, this ain't gonna do it. Whatever. Well, there is just this Super Mario Bros. 3.NES. That seems... The one that I was using ended in bin, so that don't seem right. Let's open that really quick, because I'm curious how long it is. Yes, I was definitely grabbing the wrong file. That'll do it. Yeah, that looks like a much different header. And how long are you? Look, it's the same length that mine was. Fascinating. I was doing it just fine. You can't force me to do it the right way. You can't. I won't take it. We just have to make sure. This doesn't matter, but I'm going to call this smb3.nes. Let's copy the right frickin' file. This one. Rename smb3.nes. Yes. Get rid of this one, whatever that is. I don't know where I got that from. Sure, get rid of this one. Oh, wait, no. That was the one that I needed. Undelete. Basic.rom is the one I want to get rid of. Okay. Run this again. Oh. Save also, I think it's complaining because it's open and various things. Yes. Nice. Okay, I feel good about this one. FCEUX. Open. Basic.NES. Wow, look. In the emulator, it runs so good. But of course, the emulator has all of its memory initialized to some things that make sense. So now we have to find out why this doesn't work on the console. But that's promising. So what was the actual thing that I was trying to figure out now that we have this working? We have to rewind quite a bit. So what I had just done was... It's interesting that it's all full of A's, considering you'd think it would be all full of zeros, and A is character 3. I'm not going to think about that too hard. You think FCEUX doesn't care about that wait a while to write your data thing? Let's do that. Let's read about, just in case that's screwing us up, let's read about the PPU interrupts. PPU registers, PPU memory map, PPU. NMI? Sure, yes, the 6502 does a NMI. That's known. But what does the PPU do? Two 1-bit registers inside the PPU control the generation of NMI signals. Frame timing and access to the PPU's PPU control and PPU status registers change these registers as follows. The PPU pulls NMI low if and only if both NMI occurred and NMI output are true. No. Don't do that. By toggling NMI output... You know what? Let's just look at the minimal example. Let's not get off in the weeds there. Let's just look at how it's actually implemented. example.s. Let's see what they do. In code. So reset, blah, blah, blah. So this is them disabling the NMI on the PPU. Disable rendering, disable APU sound, disable DMC IRQ, disable APU IRQ, disable a bunch of stuff that I am not. They initialize the stack, which I don't care about yet. Here, let me blow this up just a touch. Ah, interesting. Wait for the first V blank. Wait for the second V blank. Interesting. So they are doing that without actually setting up the NMI interrupt and everything, it would appear. Do they have an NMI interrupt set up somewhere? I'm not going to worry about it. But they are using... Oh, I am not super familiar with the bit instruction, but they are doing bit 2002. Let us review. I know bit does a bit test, but I don't use it, so. Bit. Oh, that's going to turn up a lot, isn't it? Bit absolute. Test bits in memory with accumulator. Bits 7 and 6 of operand are transferred to bits 7 and 6 of SR. The 0 flag is set to the result of the operand and the accumulator. So, what are those PPU bits in? That was 2002, right? PPU registers. That's the status register. So, it's literally just testing, let's see. Yeah. Presumably vertical blank has started. Yeah. So it's just waiting for this to go high and doing a tight loop. Let's steal that. That was here, right? And what's BPL? I have not seen that branch before. BPL, branch on result plus. So a branch on it not being negative, which interesting, because I guess it would be negative if the top bit is 1, and bit is resulting in is anding the accumulator with the operand, which is the value from the register. Let me look at that again. So it's... I am not familiar with this labeling syntax, but... Are they setting A to anything before this? Not really. Interesting. Like the load A with 255 here, and then they're storing it to all of the OAM sprite register locations, but they're not adjusting it before they do this. So I guess if it's 255, that's FF, so the top bit is always going to be 1. Interesting. What do they do for the first one? What is in A? Interesting. Yeah, like they're not setting A here either. Like the last thing that they do, the last thing that goes in A is load A 0, then load A 40, and then they don't do anything with A. So it would presumably still be 40? Fascinating. And that would not be like that flag is the top bit, right? Yeah, vertical blank has started. I clearly don't understand the bit instruction. And again, I'll look at chat in a second to have someone who knows the 6502 better Tell me what a dumb guy. No, not BPL. Bit. Right here. It was right here the whole time. So bits 7 and 6 of the operand, which are the top 2 bits of whatever's coming out of that register. What is SR? I should know what SR is. It's not stack register. That doesn't make sense. Oh, status register. I am dumb. The status register. And I just kind of skipped over these. The negative value and I don't know what V is off the top of my head, but so that bit 7 ends up in the negative flag. That's why it works. Right, and they're just ignoring the 0 flag. Okay, well at least now I understand how that works. That's interesting. So, the annoying thing is clearly things work pretty cleanly on the emulator because the emulator starts up in a cleaner state than the actual NES does. But yeah, maybe let's see if using that hack to wait for 3 V blanks, as you were saying, does stuff. And they mess with PPU registers before they do anything, right? I mean, should I just steal all of this? Am I disabling the NMI? I don't think I... Wait, no. Yeah, I am. I'm doing this exact thing. Okay, yeah, so... Good enough. And I'm masking. So, I'm turning off interrupts, but the NMI would be triggered anyway, but I'm turning it off, so that's fine. So these APU IRQs and DMC IRQs should not be interrupting me. So I think I don't care. So let's do this bit 2002 loop. I wonder why they're doing this twice. Do they do it twice down here too? No. So, yeah. But no reason to chance it. Let's just steal what they do. Okay. Wait for 2 V blanks. I mean, 3. I heard 3. Let's call this PPU V blank. Wait. 1. I could just make this 2 nested loops, but I'm going to do it the super lazy way. So let us start by bit 2002, like they did, for whatever reason I don't know, but let's just do it. And bit 2002, and what was the name of that branch command? BPL. BPL. PPU, B blank, wait 1. Okay, there's the first one, and let's just copy paste this twice. Because cargo cult programming is totally cool. Alright. It works for them. Shall we try it? Let's build this, build it in the emulator, or run it in the emulator, where it should make no difference, right? One would think. Make sure that's in my path. And then we'll run it on the real hardware, because clearly that makes a difference. I mean, of course it would make a difference, but... Okay, now do the horribly manual task of copying this over here. Stop hitting escape, Vim fingers. Basic.bin cd tools injector .net run, which may fail because FCEUX has the file open. Nope, that worked just fine. it worked less. Let's open the debugger and see if it's like stuck in a loop. It seems to be. It seems to just be there. Interesting. Why does this work for them and not for me? That is a real double standard. Let me move to chat. Oh, man. Oh, boy. Yeah, I figured I missed a lot. Trade MC says 5-minute break. Yeah, might not be a bad idea in a second here. We got a lot to review. Derek Cronenberg said, way back when I was working on the script, are you still spewing 64 KB of zeros at the start of that program snippet? I'm putting in 3 copies of 64K of zeros because it's 256K and I only have 64K of binary that I'm injecting into there. Cat. Cat indeed. Cat is here now. All difficulties should soon be gone. No. Run, kitty. He already sacrificed the goat. Time to pull up the format spec and see what you screwed up? No. I just power through. You could try first splitting the entire SMB3 ROM into 3 parts first, and then concatenation. Yeah, I mean, a smart person would have just, yanked out the header bytes, the character ROM bytes, and then just wrote a quick script to concatenate them, but no. No. Not here. 5-minute break was requested probably a long time ago. My cat loved to sleep on the CRT monitor back in the days. My cat likes to sit on the router because it warms his balls. Trade MC says, read about the PPU reset initialization. Yeah, I should read the actual thing. Yeah, there's a page on NES Dev called Init Code. Check that out. Yeah, Wereworm says that's the reason behind the local label that's just a semicolon, so you don't have to come up with a whole bunch of labels. Yeah, that's what I figured. I just didn't. You missed 2nd and 3rd BPL labels. Oh, did I? Is that what's up here? This is why I have you guys around. And then, yeah, legitimately might take a quick 5-minute break. But the stream seems to be holding up, so we're gonna keep on keeping on. Almost 2 hours now. If you manage to keep up with me, you are brave souls. Because this is clearly gonna take a minute with the pace I'm working at. Yes, let us look at our assembly. Yes, they're all going back to PPU vBlank White 1. Brilliant. Let's try that again. And then copy basic dot into tools injector. CD tools injector. .NET run. But I will look at that init code section. If you're gonna tell me to, fine, I'll do it. Fine. Okay, that resolved that. Cool. So let's read that init code section really quick and see what I'm doing that's dumb. And then maybe a quick break. Init code. Look, I've definitely been here before. When the NES is powered on or reset, the program should do the following within a fixed bank, which we are in. Set the IRQ ignore bit. Not strictly necessary, as 6502 sets this flag on all interrupts, including reset, but allows program code to simulate a reset by jumping to there. But we Do they mean the IRQ ignore bit in the CPU, or do they mean the don't send an IRQ in the PPU? I don't know. We're doing both, though. Disable PPU, NMIs, and rendering. And I think I'm turning rendering on, like, first thing, so... initialize the stack pointer, which I'm not using the stack right now, so initialize the mapper, which I am doing a little later on, but that doesn't involve the PPU, so... or, I mean, it's attached to the PPU, but it shouldn't, like, the PPU state shouldn't care about it. The unit code after this point may be placed in either the fixed bank or a separate bank using a bank switch followed by a jump. Disable decimal mode. We are doing that. If using a mapper that generates IRQs, which we might be, disable APU timer IRQs, but that's a regular IRQ, and we have disabled IRQs on the 6502, so it shouldn't matter. Disable DMC IRQs, that's that same thing, because we saw that in the source for the other thing. And again, we shouldn't really have to care about that, because we have interrupts disabled on the CPU, so unless there's other hardware that messes with, I don't think we should care. Set all RAM that your program uses to a known state, of course. That's just initialization, but we're not really using any of the RAM yet, so. Wait at least 30,000 cycles before reading or writing registers 2003 through 2007. This is commonly done by waiting for the PPU to signal the start of vertical blank twice, which we're doing 3 times, so don't worry about it. Some mappers have no fixed bank because they switch all 32 kilobytes of program at a time. That's interesting, but we aren't dealing with that. Okay, so I'm feeling relatively confident. Let me look at the registers that I'm writing really quick, just to make sure. I am setting the scroll registers, so let's go ahead and move me setting the scroll registers, because it said all of the registers past 2003 you shouldn't touch until the PPU settles. So, yeah, let me move this below waiting for the V-blanks, because that could matter. Set scroll to 0 and 0. Cool, and then also for fun, just because, I mean, really, I don't know. Oh, I already moved this down to 40. I was going to say move the A down one more line, but it would appear I don't have to. Let's build this, put it on the cart, see what it does. Quick break. And of course, we're going to see all A's on this because I don't know why it filled. Again, I don't know why the whole thing is A's. I don't know why all VRAM is apparently set to 30, but ours is just going to have garbage in VRAM. So it's going to be a bunch of garbage, and we should have a clean A somewhere, theoretically. But yeah, let's see if that resolved some stuff. And see if we get a cleaner A. Build it. And go straight to programming. Do not pass go, do not collect $200. That is still in the same location. All I need to do is that. Loaded. Cool. And for the first time in like an hour, switch the camera. Give your eyes a bit of a break from looking at my screen as we do the traditional pry and pray. And I apparently rest my voice for a moment. I mean, I can gab nonstop. Just ask me, just tell me what you want to talk about. And I can keep on going. Because I am... The funny thing is, I was traditionally a very shy person. And then I realized that nothing really matters. Became a nihilist. And now, I'm not afraid of embarrassing myself, so I will just talk about whatever you want for hours on an end. I think this is just part of being near 30s now. Trade MC said stream is solid. Yeah, I'm feeling it, and I'm very happy with that. Because that is super annoying. And I think it could have just been dropping my bitrate a bit. I don't know, but it seems pretty good today. So I'm happy. Program. Sun is rising in 10 minutes here. Jesus Christ, Wereworm. Do you sleep during the day? Are you a vampire? Are you writing the entire name table or just one cell? Just one cell right now. I mean, like, why am I not writing the entire name table? Because no good reason. I will need to do that in a minute to clear it all out, so that we have a nice clean background to work off of. But right now it's just all garbage except for that one cell. Alright, we are programmed. Don't get your hopes up. I fully expect this to just... Well, here's the thing. Let's say don't get your hopes up. Let's, like, institute those magic words. Because last time I said that, it worked first try when I first rote coded this ROM and executed it, so... Let's just assume it won't work, and hopefully that will help us out. Okay. I feel nervous that I'm missing a step somewhere, but let's do it. That appears to have made zero difference to anything, as far as I can tell. I don't see crap for change. And resetting it makes it just not work. Interesting. Cool. Welp. Alright, I think next step is... See, this is the thing, is I have no idea why, when I reset it, it just decides to not show anything. Could be because... I'd say it's because, you know, like, VRAM is... heating up and cooling down, getting powered on and powered off, so maybe it all gets cleared to something that's slightly less random, just by the nature of resetting it, but that's still very weird. That it just... I'm turning power on and off. Here, you can't see my hand. But it just kind of stops working. And then if you wait a minute, or you kind of wiggle things a touch, it may start working again. Or just wait a minute. Or just wait a minute. I was playing with this earlier. I'm not just, like, making stuff up. I was seeing this behavior before. Like, I would reset it. I was just playing with it a couple days ago, and I would reset it, and it would not... Like, I'd have to just wait for, like... That's why I got, like, maybe DRAM settling down and losing all of its state is the only thing I can think of. Because all I did was just, like, wait a while, and it works again. So, that's a whole interesting thing. Turn off Secure Boot. You're a smart man, Wereworm. Really thinking it through. Yeah. Let's take a quick break, and I think my next step will be... Let's try filling all of the name table with 30s, which is the A character. Just make a loop to do that. And see if that makes any discernible difference. I still find it weird how at the bottom, right here, why is that gray? Why is that gray? What's up with that? Anyway, let's just use my weight screen that I have not changed. We'll just do that. All right, 5 minutes. See you in a sec. I'm gonna take a whiz. Okay, so also occurs to me that maybe the wrong thing is occurring to me. I was going to say, there was that note about disabling rendering while you're doing PPU startup. I wonder... I think I am, right? No, because I think this is the rendering bit. Because this... I think this register is the one that has, like, the v-blank interrupt settings and stuff in it. And I think this is my rendering stuff. Let's actually see what they do in the recommended code. What do they put in 2001? They're loading FF into X, putting in the stack, using stupid clever code to set X to 0 by incrementing it and letting it roll over. Okay, so they're just throwing 0 in both of these registers at the beginning. So you know what? Let's do that, and let's do this, where we actually enable rendering the background after. But also, let us do that and fill the whole screen with A's. Both in one fell swoop, because the scientific method always says change 2 variables at the same time, and then don't worry, it's going to be fine, even though you'll never figure out which one was the thing that did it. So, yeah, I'm sure that's fine. So let us set this as LDA 1, or actually, we can just keep that 0 from there, and steal this. No, I do want the whole line. And then move this down. Nope, down here. Call this enable rendering, but then up here, right, we don't want to turn on background and sprites. Let's just rename that all to disable rendering. Disable interrupts and rendering. Nice. Okay, so that's that. Now, let us... This is our loop for writing 2.0, 4.0, and putting a 3.0 in there. And actually, the PPU auto-increment stuff, right? Let me double check how PPU auto-increment on VRAM works. So firstly, PPU name tables. Oh, you know what, actually? Oh no, I want to change it to 30. I was going to say, I could just reuse this, writing the attribute table stuff, except make the amount that I'm writing bigger and just write over the whole 1K that is the name table and the attribute table that follows it, but I'm writing 0s here, and I want to actually write 30s here, because I want A's, damn it. So, yeah, never mind. But I will steal the way this code works, so let us load X. Actually, fill the screen with A tiles. Load X. And how big is it? 3CO bytes. There we go, right there. So 3CO, and I could use those. I could use those local loop labels. I could. Why not? Let's play with that. That seems so useful. And yes, load A 23. Oh wait, right. So the whole thing is. Yeah, and actually for this loop too. Maybe I'll look at that in a second and fix these loops up, but this loop I probably also could have just not bothered doing this math here and adding the X value to the accumulator before writing it to VRAM, because I I think you can just set the address and have it auto increment by one location every single time, but whoops! Shh, don't worry about it. So for now, let's just write the same inefficient loop. So it's going to be the same thing, except we are going to write to... Is it? So this one was writing to 23... Oh, right, because it starts at 2000, but we have the offset of 3C0. Right, which is why this is BF. So we want to start writing at... I think... Oh, that actually is weird. Because here we're counting down from 23BF plus 64, which is 2, 3, whatever. I mean, I guess that would be 4. It would be 2, 3 FF, probably. Yeah. Because the next one is, yeah, it's 2, 400. But that's fine because this doesn't roll down. 2, 300 is the lowest value. But with this one, yeah. Let's use the address decrement because this high order byte of the address is going to roll on us, whereas the one for the name table, or the one for the attribute table, did not. So we need to be slightly more clever and use the PPU's auto incrementing stuff to our advantage. So let's start by setting up that address. So we'll start with 2000, then let us load X 3C0, and that after that point we will start looping and decrementing X in a loop, but instead of using that for mathing, we will just, I think, continuously keep writing to 2007 until X is 0, and let's look at that PPU auto increment thing so that I am sure that I am understanding that correctly. PPU memory map. No, that's not the registers. The registers are here. PPU data. Let's see. Oh, also that is probably interesting and important. When the screen is turned off by disabling the background sprite rendering flag with PPU mask or during vertical blank, you can read or write data from the VRAM through this port. So, yeah, that's the thing we have to be careful about, is that we shouldn't write to that port unless it's during a VBlank, apparently. Since accessing this register increments the VRAM address, there we go, it should not be accessed outside of vertical or forced blanking because it will cause graphical glitches. And if writing, write to an unpredictable address in VRAM. Interesting. So, I should actually look at the demo code to see how they do that as well, which I'm sure we can also pull the status register. Probs. I want to double check, because I think... Yeah, one of these flags in the 2000 register controls the increment size, and we're setting that all to 0, and 0 is increment by 1, so... But yeah, that could also be part of a problem, is that I'm not waiting for VBlank to jam data in there, and it's just going screwy. That would also make sense. Let's see what the example code does when they fill memory. Oh! That makes sense now, actually. I see what they're doing. So, I was wondering why they had a loop here waiting for VBlank, waiting for the first VBlank, and then they're writing to OAM, which I assume is a similar story. But yeah, perhaps that is what's up. Is that they wait for a VBlank and then they are doing stuff to memory. So let me actually do that, because I'm going to use that same code to wait for vblank before I do this. Let's just copy that code and use that local label thingy. Sort of making RS-232 terminal for NES. It's that we're kind of the goal is almost to make a terminal emulator, sort of, in that we need to be able to write characters to the screen in a way that's like a glass teletype, where it just will do a character, and scroll the screen when it gets to the bottom just automatically by dint of putting a character on the screen. But the point of that is because I'm trying to port Microsoft Basic to this thing, which will take a long time. Trust me, I understand that this isn't going to happen anytime soon. And really all you need to implement that is to implement a get character from keyboard routine and a print character to the screen routine. So we're figuring out how to print characters right now. This is our first big leap. Did I not say basic? I don't know. It's midnight. I mean, I'm sitting here complaining, and Wereworm is like, I've been up for 3 days. Yeah. Anyway, so let's try this thing. Let's use this magic 2002. And I do not remember the name of that. BPL. Oh, is it that? Is that the previous label syntax? Sure, hopefully. And hopefully that should wait for a vblank to happen. Heck, that might also be why that one row of characters is coming up gray and getting the wrong palette, is maybe I'm able to, like, it's just lining up just right that I'm able to write some palette in a window when a vblank is happening when the thing starts up, and then it fudges up towards the end. Though it starts from the end, so that's still a little bit weird. It starts from the end of the attribute memory. Yeah. Anyway, but yes, so the auto-incrementing thing is correct, so I should be able to just load A30, write it to 2007, it should then auto-increment itself, and then decrement X, and I can just, yeah, branch not equal on that. That will set the registers, I think. BNE, which is the same thing as branch if not 0. Use that previous label magic. And I think that's it. I think that's all I wanted to do. So now we are still setting this, so we're initializing both the primary PPU control registers to 0 and turning off rendering while we do our initialization. Then we're waiting for our 3 vblanks in this very ugly explicit way. Then we are turning on rendering, which I'm also turning on sprite rendering for no good reason. Then we're setting the scroll registers and writing the palettes. Actually, let's also be real explicit here. Let's do that same thing and wait for a vblank. Vblank. Bit 2002 BLN BPL like that. Then set the palette values once we've made sure that a vblank has started. God knows if we have enough time during vblank to make this whole copy happen, but let's just not worry about that right now. Then set the whole attribute table to palette 0. Set up the MMC3 to map that correct location that has the characters we want. wait for another V-blank, then fill the screen with A tiles. And have, again, hope we have enough time during the V-blank to successfully do that. Fingers crossed. I think that's all I needed to do. Remember, the bit needs a 40 in A. 40? Shouldn't it... Wouldn't it be 80, if anything? Because that's what I was trying to understand in... Was it this code? Yeah, it was this code. So they put a 40 in here to disable the APU IRQs, because apparently that's what you need there. And then they don't do anything with it, so there should still be a 40 in here when they do this bit. Sure. But then when they do this one, the value in A is 255, so technically, and then they don't change it between here and here. So yes, it would still have the 4-bit set. But that said, in the 2002 register, the 4 position in the high nibble is the sprite 0 hit register. So I would expect if anything needed to be set, it would be bit 7, which is the 8-bit. Am I insane? Because, like, I would agree with you. I think you're right. That's, like, what the bit command says, is that it masks with what's in the accumulator. Oh, wait, no. We're both going crazy. It's because it doesn't use the masking part of it. The 0 flag is set to the result of the accumulator and the operand, but it puts bit 7 and 6 into the status register negative and whatever. Oh, overflow. Right. Don't confuse me, because it took me a while to figure out how this worked earlier. So since bit 7 is the are we in V blank bit of that status register, and that goes directly into the negative thing, you can use basically the branch if negative instruction to deal with that. That's why. So that's why it doesn't matter. I had to re-remember that all over again just now. Thank you. It helps it embed it into my brain better. 104, I am doing something bad. Oh, I'm trying to load a value that's bigger than FF in LDX. That would be an issue. What's my best way of dealing with that? Because I could do a nested loop situation. There's probably a way to make the DMA do this too, because I know there is a DMA for copying stuff into VRAM of some sort. Oh, wait, Wereworm, you're totally fine. I just, don't worry about it. You helped me reinforce that into my brain. Because, again, I was wondering the same thing. 88T says, when understood how memory nightmare bank switching works and how many varieties of NES there are, for each one you have to modify the code. I abandoned NES and write code for the Sega Mega Drive. Yeah, I am getting that sense. For sure. Okay, so F it for right now. Let's just set it to FF. And we'll just do the first 256 characters on the screen. And we will deal with doing them all a little bit later, because we just need to prove that this is working the way we want. And actually, I'm going to set them all to 0 right now, because in the emulator, they were all A's for whatever reason. And so this should... I don't know what the character at the 0 position is, but it should fill the first chunk of that name table with whatever that first character in the pattern map is. Okay, that seems to have built. Let's go through our overcomplicated rigmarole of copying basic bin into the injector folder, going into here, running the injector script, and starting our emulator. And see what it does. It's still all A's, which is suspect as hell to me. Oh! Oh! Interesting. A is the first character. There's 2 copies of it for some bizarre reason. Probably because this gets mapped slightly differently when it's actually used in the game. Like, those characters up there probably get used for something slightly different. That's why it's all A's. I see. Okay, let's try doing it with 30s. Which should be the other A, which as you can see is paletted slightly differently. And I should turn this all into one script that's like make emulator ROM image or something, but later, when I have time. We'll build it. Copy it to injector. Go over to injector. Run injector. Start the emulator. Yeah. Stupid start menu and your Bing advertisement built in. FCE units. Open. Basic.NES. A. Okay, so that at least shows that it works on the emulator, but who knows how forgiving this emulator is. Let's stick it on the chip and see if it makes a difference over there. Like, a lot of that setup code was actually for the real hardware, so the emulator is just a sanity check that, like, we're not horribly broken in here, and it's actually running all of the code and not getting stuck anywhere, or running off into space. So, we should already be set to load it, write it, run it, go for it. That's not the right, that's not the right camera. There we go. Turn this off, pop this out, continue the cycle that I wouldn't have had to do if I had found that ZIF socket. It's somewhere, man. Like, I set them aside somewhere, and I don't know where that was. But I bet it would work. Jamming a ZIF socket into the Tower of Power. Program. Insert. Program. Verify. Remove. Reinsert. And then we can hopefully stick to doing more development with just the emulator once I am relatively satisfied that this is actually starting up and initializing correctly on the NES. And we can mostly, hopefully, just sanity check on the emulator and do the occasional moving things over here just to prove that it's still working. All right. That's an improvement. We're definitely doing stuff. The characters are definitely getting written there. The palette is effed. The palette is weird as hell. I wonder what's up with that. But you replace the EEPROM with a dual port RAM, rapid development. You're not wrong. That's just a lot of work that I don't feel like doing just now. Okay, so we're getting there. So now the question is, we can write the characters to the screen. I think most of the garbage is because it's actually rendering sprites. And I think those are just all random sprites all over the place. So actually, I should turn off sprite rendering in a second here and just run this again. But the next thing clearly to figure out is why the attribute table is getting set up so weird. Because the attribute table should be all zeros. And 'tis not. So is it v-blank related? Is it because by the time we're getting up to the top there, the v-blank is over and we're starting to write to random areas of memory? Could be. I don't know how much work we can do during a v-blank. Yeah. Trey Dempsey says it's different. It sure is. Sean Lucas says, where is the FPGA dual-part memory from the VGA card? It's in the VGA card, and I found it the other day. It was just right over here. It's in there. It's right in there. It's still sitting there. I haven't done crap with this card. We will. We will. I put too much work into this card to not do future things with it, but right now we're focused on the NES. Low-level men are hot. Changed my mind. I'll take it. I think my wife would agree, but, I mean, maybe not with the low-level part, but she seems to like me, so. Yeah, Trey Dempsey says you should turn off sprites and move them off screen. I'm thinking exactly that. And, I mean, maybe for testing the theory of maybe I don't have enough time to set all of the... You know what? That loop is so inefficient for setting the attribute table. That could be part of... That was interesting. That could be part of what's screwing things up. Because, like, all of the... It's not until you get to the top of the screen that it starts getting screwy. And we're setting the attribute table values from over here to up there. Not from up there to down here. So, might be that it's such an inefficient loop that it's taking so long that it's not able to complete it before the end of v-blank. Which, I mean, we could do this the straightforward way. You know, this might be the way to go. They said, or just turn off v-blank if you want to do stuff. Or, turn off the PPU. Stop the rendering. What if I just do that? Just to make damn sure. Turn off the PPU rendering until we have finished writing everything to VRAM. Let's try that. I think let's try that. Also for fun, did that at all improve the power off, power on experience? Oh, it really did. It really did. That's a big deal. So I'm sure that's why it was probably doing really weird behavior when I would turn the machine off and back on, because we weren't really initializing things properly. So that's big. That's good. So let's turn off sprites entirely. Let's just never turn them on. And let's not turn on rendering until right before we get into our halt loop. You agree? Also for fun, while I'm here, because I was thinking about this. Remember this guy? Remember these guys? If you were here before? Theoretically, if everything is running correctly, the NES is sitting in a loop right now, copying the status of one of the controller port pins to another one. So if that's working correctly right now, this should still be reactive. Let me get this in the right hole, he said. Let's just make sure I don't fry anything. Is that the right thing? No, this is the right thing, and it's working fine. Cool. All good signs of life. Alright, let's do those things that I said. And I'm going to put my headphones back on because I have not been listening to music, and that is a real shame. And let us crack a subsequent beer. Oh, Trey says 2,387 cycles in a V-blank. That is good to know. Because I don't know the relative speed off the top of my head of the CPU clock versus whatever NTSC refresh time is. Is it like 30 hertz? Set a breakpoint at the end. If V-blank in FCE, then you can see how far it gets. I'm going to need you to further describe that. I'm sure that totally makes sense. I'm just too dense to get what you're saying. Set a breakpoint at the end of V-blank. Oh, in FCE, the emulator, FCE UX. Then you can see how far it gets. Oh, no, you're right. You're right. That makes sense. I'm not going to right now, but that's smart. 88T said, excuse me if I seem like the captain of the obvious. Maybe you need to make a function to write a bunch of zeros to the video memory? Yes, we kind of already are-ish, at least for the attribute memory and the palette memory, but you're not wrong. Yeah, I mean, it needs to be initialized, but all of those other garbage tiles that are on the screen are expected to be there because I'm not clearing out any of the tiles. But the fact that the palette is inconsistent is the weird thing, because I am setting all of the... I am explicitly setting the palette, and I am explicitly clearing all of the palette values for that name table, so that's the weird thing. Yeah, so let's just start simple. Where was I turning things back on? V-blank, V-blank, V-blank. Yes, the enable rendering. So just delete this and move it all the way to the end. And for rendering, let's make sure sprite rendering is off. Registers, right here. I was there. I was in the right spot. Yeah, this one does render control. Show background is 8 of the low nibble. Wait. Oh, what else am I turning on? Oh, yes. Because I had these both set to 1. Oh, right, it's E, so it's 1110. So that is showing the background, doing that. That's fine. And I just need to turn the 1 bit off in the high nibble. Okay. And I'm not going to sanity check this in the emulator yet, because I'm a madman. I'm sorry. I did this thing again. It's always switching back to the display for some reason that I just always F up. Sorry. But yeah, all I did was took this guy, which was right after the wait for V-blanks, the wait 3 V-blanks, and it was 1E, that one was turning on sprite rendering. So we wait until just before the halt loop to turn any of the rendering back on, and don't turn sprites on at all. That's the only change. And I built it already. And we're going right back to this camera again because I just can't stop using this camera. If this keeps up, I may try looking for that ZIF socket again. Because, man, that would be convenient. And I bet it would work. Talk amongst yourselves. It's in. Program. I gotta say this every time. Program. Programming flash. Verifying. I'm not gonna switch to the display. I'm just not. You can't trick me. Because I'm coming right back here and just trust me, it's verified. And back in we go. And now we switch to the proper view. Turn it back on. Yeah! Yep, so that was definitely it. Solved. Ish. Still don't know what those, Oh, well, those are just garbage tiles. Okay, that's fine. But, yeah. Okay, so the dangerous part for us is doing stuff while rendering is enabled. But I don't care. We could actually work with this because the only time we need to do like a big screen. Okay, actually, let's think about this. I definitely need to do a big screen fill when we first initialize everything to clear the screen. Now I was gonna say, but after that, I'll just be like writing one character at a time, and like as long as I wait for a V-blank to write characters, probably fine, and like writing one character is going to be NBD. But what about when we want to actually scroll everything when we hit the end of the display? Let's, Trade MC says probably just need to disable rendering. And he already told me 2,387 cycles in a V-blank, so we should be able to work backwards from that if we need to. But yeah, he says, I don't think you can write the entire OAM and name table in a single V-blank interval, which I find believable. But yeah, let us... I should be able to figure out, looking at this, firstly... Actually, I already know, just looking at it, because there's so few palette values, so few colors in the palette. For these characters... This actually kind of sucks. Oh well, I don't care. Clearly, so black is our background color. So the black area of the A's is actually technically transparent. But whatever, it's not like we're going to be overlaying anything. So I could just set my background color to white. And then... I mean, not that we're not forced to just use white on black, but let's start there. And then palette color 4 is what that orangish color is. So I need to set palette color 4 to black. I need to set palette color... Oh, I didn't even think about that. So I'm assuming that there are going to be like other like numerical characters and whatnot somewhere else in the character ROM, right, for me to use. I would bet that they don't use the same palette numbers. So, let's not worry about that too much right now. For now, yeah, I guess let's clean this up. Now that I know how to roughly get things set up and what is causing me problems, let me clear the entire screen, alter the palette so that my background is white, and my color 4 is black, so it looks like computer text. And I'm gonna need to find a tile that is all color 4. We should actually be able to do that really quick in the emulator. That's what the emulator is very good for. Let's look at that really quick. Let's use the injector script really quick. Yeah, because if we run this now... Yay, look at that. And we go to the PPU viewer. It it looks like, yes, like these look usable, I think. Oh, okay, so we at least have a period, an exclamation mark, and a question mark. That's good to know. And we have 1, 2, 3. And that's it. So maybe if we just, what if we just do all of our numbers in... There's also no... Well, there is an O. We could just use O for 0. And then we just do it in base form. Just do all of our numbers in base form. Oh, we do have these ones. What if we just used these ones? What if we just said F it? Actually, these guys down here, if I set the palette right, it looks like the background on these numbers is color 4, which is going to be our black, like, screen color. And then, like, the outline of the numbers is either color 2 or 3. And we could just set that to the same thing as the screen color, and then set whatever color is the purple one right now to the same thing as our, just set it to white. That seems like heck. We might be able to get away with just, for the most part, just using this section the more I think about it. Which makes me feel good. Okay, well, let us work on clearing the whole screen, and then we're getting pretty close. I can definitely... Yeah, let's clear the whole screen. We'll just disable rendering anytime we make a change to the screen. How about that? And so for starters, I can just switch this to... Lord, what's the index of... this is 30... Oh, right, each of these rows is 16 tiles long. Right, so this is 0, this is 1, 0, yes. So 1, 1... Oh, wait, these might have things on the edge. Is there a better character? Yes, right here. Oh, that's very convenient. They have one for each of the palette colors. So actually, 7E. We want to fill the screen with 7E. And we want to do the whole dang thing with blank tiles. And these were 7E. And let's just update our palette right now. At the very least, update... We'll set our background color to... Right now, 0D is black. And I want to set it to white, which is 20 or 30. Let's use 20. That seems nice. And then color 1 and color 2 I'm not going to care about right now, but color 3, or as I've been referring to them, color 1, color 2, color 3, and color 4, which is really an incorrect way to say it. Switch this to a black, which I guess I can just use 0D again. Just swap. Alright, so if I build this and run it in the emulator again, I'm just going to write another script. You can't stop me. Actually, what if I just... Because right now, link script will output my basic.bin, but there's no reason not to just also include building the NES ROM. So let's just do that all in one step. Copy basic.bin to tools/injector, and then cd tools injector and .NET run. Okay, so that should do the whole thing every time. So I don't have to keep retyping that a bajillion times. Looks good. And probably should have unloaded this ROM first, but let's just try opening it again. Cool. It was perfectly happy with that. And now our text looks more the way I would want basic to look. I will update these palette colors later. Now, let us fill the whole screen, which is going to be annoying because I am the dumb, and I need to write 2 loops to write 3C0 worth of memory, but how I break that up into, you know what? We use the calculator. This is what we do. And we go to hex, and we put in 3C0, and we divide it by, I guess I could divide it by 100 hex, and that'll be, of course, it's dropping the C0. So, I mean, do I do, like, should I do a loop of, I mean, I guess I have to divide it by, again, this is, I am the dumb, because a register only goes up to FF, and it's going to break at 0. But when it hits 0, no, when it hits 0, that will be the FF iteration. So, I mean, I guess an alternative way of doing it is I could just do, like, 3C iterations 10 times, all talking in hex. That's one way to think about it. Yeah. That could work. That could work. Let me see if you guys have any thoughts. Trey Dempsey says, you're going to need to make your own CHR ROM. White on blue C64 style. There's a lot of thoughts here. I like a weird console color. Or amber, also valid. I don't disagree. Amber is nice. I don't have a single amber monochrome monitor, and it makes me so sad. I agree, green on black is retro. Nested loops, or better yet, unrolled inner loop. That's a thought, because I could do 16. Actually, with the way we do that, the PPU does auto increment on write. That's not a bad idea, because the only line I'd have to write is the like, I just load A once and then do call store to the data register 16 times and then do that 3C hex times. I like that. I like it. Where is my current fill code? That's me setting the palette. That's me setting the attribute values. This is me filling the screen with blank tiles. Yeah. Yes. So, what we can do is load X 3C, then load A07E outside of the loop, and then store A 2007 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 times. And yeah, and then decrease X once. That should be fine, right? And then 3C multiplied by 16 is 3CO. And I don't need to reload A anywhere in there. Yes. Does that make sense to you? I mean, I'm just seeing +1 on unroll the inner loop, so I don't know. This is built to go a little bit faster, so let's just load it. Oh, frickin' right. I have to CD back to my working directory here. Fine. Yes. That looks right to me. Since we have these nice emulator tools, let's look at the name table viewer. That looks right to me. I don't know about you guys. That seems right. And then, just for good measure, let's write an A. Let's do it. Write that damn A again. It's 2006 and 2007, right? Yeah. So let's do that old classic load A. Let's put it on the, I don't know, third line again, I guess, which will be 40. So load A 20 store A to the PPU address register 2006 load A. What did I just say? 40? Sure. Store A 2006. And finally, load A, that good old number we all know, the 30, and store that in the data register. And by God, I think this will be an A on the screen. My gut feels it. It just feels right. Or not. Or just totally fuck up something. The hell? Is there an A like off the side of the screen that's not getting rendered or something? Now clearly this not getting written is effed up and not correct. And I don't know what that's about, but oh yeah, like my scroll is off. Why is my scroll here? Shit. What? What? Y'all got any thoughts on why? Because that explains why we can see all these A's, but why did the scroll get messed up? Optimizing for speed before it's working is what makes a true hacker. Yeah, that's what we were definitely doing by unrolling that loop. 100%. Did I write to the wrong thing somewhere or something? Like, where could I possibly be screwing with the scroll? So the scroll is 2005. Am I writing 2005 somewhere where I shouldn't be? Let's look at all of our references to 2005. Those are it. Those are the only ones. God damn you. Well, let's just move that to after we have filled things out. Why would the scroll be different? There. Are you happy? Because I sure am. It is there. We have an A. Yeah, I totally did set the scroll position during init. It's just I did it before I wrote stuff to the screen. I don't know. If it works, it works. That's what I say. Caffeine. Beer. As we're going on hour 3, and most of you seem to still be there, which is wow, because it's almost 1 a.m. East Coast time. Let's put it on the cart. Let's just put it on the cart, and then let's write... I'm at least committing to let's write a... feed in an ASCII character, print out a character code. I'm not committing to string print. I am not committing to actually properly scrolling the screen, or maybe I'll commit to line breaks. But I'm committing to that much. But let's see this A on real hardware. You know what? God damn it, we deserve it. A is way better than Hello World. That's why they don't say fucking Hello World, they say fucking A. And that's just a statistical fact. Alright, vote now in the chat if I should go find the ZIF sockets. Because then you can see more real hardware stuff more often. I often wonder whether pursuing a career in embedded development would be interesting or just painful. Okay, say it with me now. Load. Offset. Hex 10,000. Program. Program. Programming Flash. Verifying Flash. Succeeded. Oh, but I bet the ZIF socket will fit in the regular socket. That's the thing. I almost guarantee it. It's in. Power on. Oh, that's just nice to see. Very happy about that. Very happy about that. All right. I guess let's write a character routine. A character writing routine. So this shouldn't be too bad, because let me look at that layout of those characters in the character ROM again. Oh, I killed the emulator. Let's look at the PPU. Yeah, so they appear to be laid out linearly. Oh, god damn it. Wait. Yes, god damn it. It's not... Why didn't anybody point this out to me? There is no... I mean, we could just stick to uppercase characters. That's not the craziest thing that's ever happened. But anyway, I often don't complete my thoughts. Sorry about that. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Oh, wait. Do we have... No, I still don't see a Z in lowercase. My point was going to be, it doesn't look like we have all of the lowercase characters. I guess they're the ones up here. We might have to do a special case for that. Let's see. Because these are... Okay. These are in order. That's going to be easy. We might have to, like... I might have to make a lookup table to do this. I was figuring I could just do, like, a... Take the number of the character, subtract the base of A in ASCII from it, then add the character number to it, or, you know, the, like, 30 to that value, and we'd be done. Which we will be for uppercase characters, but lowercase characters, like, this starts with Q. Q, R, S, T, U, V. A starts on this line, so it's A, B, C, D, E, F, G, blah, 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 over to P. Then Q starts up here. At least I can do it in ranges. Then it gets to V. Then W, X, Y, Z are all going to be their own special case up here. That's fun. I mean, it's not like that's difficult. It's just funny. which honestly kind of makes me love it, because the dumber it gets, the more I love it. Trey Dempsey says, I still think we need to make a char with our own font. Trey, you're not wrong. You're not wrong. It just, it's not, it's not the point. Yeah, I think Trey knows that I'm using the Super Mario Brothers 3 character ROM. It's just that I want to make it work without changing that character ROM. Again, this whole project is dumb, and that's one of the things that's just a dumb thing that I'm setting for myself, that let us just keep hacking what's available in the character ROM until we have something that's roughly usable for printing ASCII characters. All right, let's write our first subroutine, ladies and gentlemen, and all other types of identifiers that you may choose. Yeah. So, actually, let's yank this. And you know what I'm gonna do? So we'll enable the rendering, and then we'll go into the echo loop. And down here is where I'm going to start the print character subroutine. Where you're going to have the character in A. And then that. So let's start with the easy capital letters way of things. And oh, what I was saying is, I think what I'll do is, since we're enabling rendering, let's use the old bit 2002, which is going to be a very inefficient way of doing this, but bit 2002, because I could also just turn off rendering for a second, but that could potentially lead to screen flicker. I don't know. Who cares? Who really cares? And then it was BPL. Got it this time. Back there. So, wait for v blank. Then we will go ahead and so there's the fun thing, right? Is that we do have to think at some point here about keeping track of where our next character will be written. Which is, I mean, that'll probably just be as easy as, like, let's keep 16-bit value in 0 page and reconstitute it here. But for now, I guess let's just keep printing it at the same location. And I'm gonna put it one line up. And we can work on incrementing the location as we go. And then this is the part where we're going to need to look up the character. So for now, I think I'm just going to, you know what, let's set up the stack too. Let's do that all the way to the top, because that way I can just push A onto the stack and pop it when I need to actually do the calculation. So let's just do that right here. Now the A, and it's transfer A to S. Is that right? TAS. TAS. Puts A and X in. Whoa, what? The stack pointer is 16-bit? No. Really? I thought the stack was always in the second page of RAM. Am I wrong? Wareworm says, what's lowercase? Trey says, who needs lowercase? Trey says, just track column and row. Yeah, I guess so, and then I can do math and reconstitute that into a VRAM address on the fly. That's probably a good call. But anyway. Unless there's... Are there... Okay, I need to, like, look at the 6502 manual again, because I thought the stack pointer was just 8 bits on the 6502. Let's look at WDC 65 CO2 datasheet. I realize it's not the same processor, but it should be close enough. I don't imagine that the stack pointer is different. Stack pointer. The stack pointer register is an 8-bit register. So I'm clearly not understanding something about what I was just reading. And yeah, the stack page is always the second page, right? Yeah, SP is 8-bit. You know, again, I could just look at the code here. But no. Yeah, that's what I thought they were doing. Oh, but they do it from X. I'm just going to do the same thing. TXS. Because maybe TAS is not the instruction I think it is. And that just solves that. So now, I can push A really quick, and then use A for all of this stuff. And instead of just loading 30, should I put a subroutine in the subroutine? PLA? Or, what is pop A? Can you tell I haven't written 6502 assembly in a minute? Push A. Oh no, it is pull A. Haha, I do know what I'm talking about. So we are pushing A on the stack when we enter here, and then we're going to pull it right before we calculate the character value. And what we need to do is, I am going to start it the dumb way, and let's just, what is sub? I feel like it's weird. Is it SBC? Yes. And of course, I'm going to be inefficient and paranoid, as I always am. Clear carry. SBC. We're going to subtract. You think this assembler supports ASCII character values? Let's subtract A. And then add with carry. Wow, 30. Which, of course, if we are over, then we'll start printing Qs and such. But let's not worry about that right now. And then RTS. And we should probably put a label here. Give it a nice cryptic short name, because assembly loves that, even though I'm sure this assembler can support nice, big, fat labels. And I guess let's enable rendering and try printing a B, maybe. Load A. And again, I'm assuming that that works. I wonder if I have to put an immediate before that. This is probably complete nonsense as far as the character literal. And JSR, that's right. JSR printure. And hopefully that'll print a B. Does anybody have no CPU cycles left behind? That's right, I'm going to use them all. We don't want to waste the performance of this machine. So to not waste the performance, we need to make sure that we execute as many cycles of instructions as we can. Yeah. Caps lock, huh? No, it wasn't. You're lying to me. Link it. Build it, link it, emulate it. And the scroll is scrolling again. What is up with that, y'all? No, that's not what I wanted. Let's look at the name table viewer. And yeah, see, it worked. But it scrolled by a character, by a one line. Doom might take a minute. I'm gonna be real honest. Why every time I write a damn character does it scroll? Is it because my waiting for v-blank stuff is incorrect? Here, let's just go full beast mode and disable rendering while we are writing anything to VRAM. Let's just do it. That one's the enable. This one's the disable. Like, I don't know why that would upset scroll, but meh. Oh, and actually that would be, because it's just the top bit on that, so 0110 is 6. Ship it. Nope, that didn't change a damn thing. Scroll needs to be reset after changing stuff using PPU address. That's interesting. I bet that is described in the NES Dev Wiki. But, of course, my reading comprehension is nil. So, or 8-bit crisis, Wereworm says. Wereworm, how are you not dead at this point? Like, what o'clock is it in the morning? And how much meth are you on? We need run C-Matrix on NES terminal. That's gonna be win. I don't know what C-Matrix is. I'm so sorry. I'm so sorry. Okay, so like just every time that we do this, we're gonna need to reset scroll. That's fine by me. That is totally fine by me. That, I dislike that less than having to enable and disable rendering every time. Yeah, so all we should need to do is load a. I don't know why I'm always writing it as a hex 0, but it's not like a hex 0 is different from a decimal 0. And then store a 2005, store a 2005. Build it. There we go. You're a good one, Narion. Thank you for that tip. I'm not sure why that's the case, but that's very interesting. 7 a.m. and no coffee until now, but second beer. Staying up all night and then drinking beer in the morning. It's not that I am going to judge you for it, it's that I don't know how you're awake. I would be, if I had stayed up all night until 7 a.m. and then had a beer, I would be out. But I'm also a dad now, so I'm always tired. And I was always tired to begin with. All right. We are at 3 hours and 15 minutes streaming. Let's see if I can print. You know what? Just because it's going to make life easier for testing, let's go ahead and track our position on screen. Let's do it, and write a print string function. Fine. Because it's going to make testing easier. What was I going to do? Let's start by figuring out what the syntax in CA65 is for defining constants. Okay, it's literally just this. Lovely. Yep. Nice. So let's make screen X is going to be, I guess I'll just start at 0 page address 0, and screen Y is going to be address 1. Sure. Alright, so as we are initializing things, let us initialize screen position, load a 0, store it at, what did I just call that? Screen X and screen Y. CMatrix app is for Linux. Unix is just make it look like the monitor from the Matrix movie. That would be pretty dope. To make it simpler, just implement printing on a single line. Trey, don't you hold me back. Don't you hold me back. Okay, fine. I'll just increment screen X for right now. Okay, so we have those. And then let's just start by every time we print a character. Yes, every time we print a character, So I want to start at, yeah, let's actually start the screen position at 20. Because if I put it on the very first line, it doesn't render on screen. So screw it. Let's just, it's not like this is that much harder. Actually, so we'll set screen Y to 1. Or alternatively, we could just always add 20 to our address. That's an option. Because we always want to skip that first line, so we could just make line 2 the first line. I don't know. My brain is rapidly shutting down. Okay, so let's, yeah, like that shouldn't be too bad. Like we're just gonna ignore byte boundary wrapping for now, which will also should be relatively easy to solve. But for now, let's just load a screen Y, and can we just do a shift? Because for every screen Y, well, it'd still be a loop either way, so whatever. So actually, can we load X screen Y, and then start A at 0, and then again we're gonna have to deal with wrapping here in a minute, but I'm not gonna think about it too much right now. And then do that super nice local label thing again that I am becoming infatuated with. And we will add with carry. Screw it. Let's ignore the carry for right now. If we're ignoring everything, ignore the carry. Don't worry about it. It doesn't exist. And we will just keep adding 20 to increase, because every line is 32 characters long. So, yes, that seems reasonable. And DEX BNE. There we go. I think that should be rightish. That will, in a very, because you can't multiply on a 6502. So there's your loop. And then we will add, again, ignoring the carry, just shh. We will add the ScreenX value. And then finally we will store that in 2006. And we're not going to increment screen Y right now because we're just going to stick to one line. And we are going to, let's see, doesn't really matter when we do it, but let us load a ScreenX. There is definitely a more efficient way to do this. But we're not about efficiency right now. We're about making sure every cycle has an instruction. I guess ADC 1 and store a screen X. And so now this is doing the rough math. Like, we should be able to go down a few lines at least before weird wrapping starts. So that's fun. But ignoring that, this should shift us across the screen, and when we hit the end, it's gonna go to the next line, but not because the math is right. It's gonna do it because it's wrapping. But don't worry about that. So that should be enough hackiness that this might work. Let's go for it. Let's do it. I pray that somebody in the chat is telling me why I screwed up royally. fceux.exe. Totally didn't work at all. Cool, cool, cool. But at least I can debug it. Right? Is it off in space right now? EOF1. No, that seems reasonable. Let us set a breakpoint at... Let's see. If I see anything that looks familiar. Where is our... So... Okay, yeah, that's our ending, that's our loop. So I guess let me put a breakpoint at EOF8. And let's see what actually happens. Actually, before I do that, I am going to set our PC to E1000. Hit run. Is it running? Clearly don't know what I'm doing. But I have also found that this this debugger kind of sucks. Let me read. Should we tell him that there is a NES OS with PS2 keyboard support? You're not going to hurt my feelings. This is just for me. Yes, line 2, always the first line. Good to know. On Sega, someone thought of doing division by bit shifting, saving up to 32 CPU cycles. I don't know the details, but maybe it applies here too. Yeah, there's lots of fun math that you can do that away. I'm just doing the bare minimum right now, so thank you, but no thank you. I guess let's just reset it and see if it works. Yes. Okay. We are at EOF8. A has 48 in it, which seems reasonable. And we're going to wait for that. Actually, I should set a breakpoint at EOFE. So that I'm not sitting here spinning and waiting for the V blank. Make sure that is set to when executed. Okay. Hey, look, it's some scrolling. Fascinating. And so we so A was 48, but oh, here's the stack right here. That got on the stack successfully. Good. Load 20, store it into the PPU. Load X, the value from 01, which that's our character X location. And load A0. Add. Oh, yep, so that should increase, and X is 0, so that should not branch. Cool. Then we add the value from our X offset, which is nothing. Then we load we load the X value into A, we increment it by 1, and we store it back. Then we are storing A, which is, oh, what a moron. There's your bug. We're effing up the accumulator right before we actually write the value into memory, or into VRAM. So let's fix that. Wait. No. No. I'm getting ahead of myself. We're storing A to PPU. No, yes. Yep. So because that's the part that is writing it to the address register. So we want to put it here. So that it doesn't get, so that our actual calculated value properly goes into the address register the way that it should, instead of becoming 0 or 1. Smart. Still not working, but hopefully we're getting closer. Why is it at address 0? Is it because I had breakpoint set? Hi. Hello. Hello, all. We did it. This is also like the most basic stuff. Like, you would need to write this in an NES game anyway, to like, if you wanted to have characters say something. But I don't know what I'm doing, so cut me some slack, you know? We're here having fun. But we have said hi. So we can definitely print text on one line now. I mean, to print on multiple lines, we just have to handle the Y wrapping. And we need to handle all the other characters, but hey, you know what? It's 1:23 a.m. over here. I've been streaming for 3.5 hours, which, I mean, we knew this was going to be a long stream, but here's what I'm going to do. We're gonna write a print string that just takes a base address and have to think about how to pass that. I guess maybe I can pass the base address and the combination of X and accumulator. Anyway, pass the address to a string. Don't expect the string to be too long. Maybe assume that our strings are always aligned to... No, that's probably too complicated. I was going to say aligned to a 256 byte boundary. Anyway, let's write a print string something. So I can write hello world and we can get out of here. And then I can clean it up later. Print string subroutine. So let's think about how I want to do this. Because we could pass arguments on the stack. That's an option. Our address. Or expect the string to be in 0 page. There is, I think, a way to do like relative addressing where you reference a 0 page address that is the base of a 16-bit value in 0 page. That will be the address. Ugh. Using addresses is so annoying on 8-bit machines because you can't deal with an address-sized value very easily. Did I set out to do more than I set out to do at the start of the stream? Because I wanted to... Was it just an A? I don't remember what I said anymore. I don't know. I don't know. Let's just do... Again, let's do this in the dumbest possible way and fix it up later. Let's pass... And the 6502 is so frickin' simple that doing address calculations blows. Because if we pass the address in like X and A, then what addressing modes do we have for loading data? That's really the question. Because I don't remember at this point. Because we need to get creative with those. Let's see what modes load A has. Because I know there are some indirect modes, but I need to be able to be passed X-indexed indirect. Because I wonder if we might just... And I'm going to have to care about this later too, because BASIC uses 0 page addresses, but I was looking at the source and you can specify as a build parameter how much 0 page space to reserve for, you know, like the rest of the system, like especially if you have another ROM in there that does your character I/O and it needs 0 page addresses. You can tell BASIC, hey, only start using them past a certain address. But I think maybe for now, let's just... Yeah, because one of these modes is, like I was saying, we could put a address, a 16-bit address in 0 page, and then specify the 0 page, the 0 page address, which would just be a byte, as our argument for the base of the string pointer. And then use X to, or Y to relatively address it. Let's see. Because these are different, indirect X and indirect Y. And it's because, so the parentheses are the unindirection, or I guess the indirection. So this will take that 0 page address, maybe? I think. think that's... I think. Well, it says it's 2 bytes long. So yeah, it's got to be, because it'd be the opcode, then the 0-page address that the address pointer is at. Or the 0-page address pointer. Anyway, so this will add X to the address before dereferencing it, which we don't want. We want the Y version of that. Right, because we want it to look at the address in 0-page, dereference it, and add Y to that address. So we're going to use this, and we're going to say to the user, you have to put an address in 0-page, and then give me the 0-page address of that address pointer. Trade MC says, I thought it was just an A. It might have been. It might have been. Now it has become this. So this is going to be the core of our stuff. Load A. Oh, but that's... The 0-page address here is... It's actually the... It's not indirect. Fuck. It's going to be, like, it's hard-coded into the second... Okay, what if we just always say there is a 0-page location that is the print string pointer? There are, I'm sure, better ways to do this, but this is how I'm going to do it. So let's just always say, I don't know, 0-page. We'll do the same thing like we did with character X and character Y. Load a, I don't know, let's call it string pointer. And let me define that. Throw that at 03. And where were we? There we go. So, we will... Actually, I suppose... Well, yeah, this will just be a straight-up easy loop then. Because this will be... we will clear Y. Can you directly address Y? Yes, you can. Cool, so we'll clear Y. Now, I already forgot what... It was going to be indirect Y, right? Yes. Yes, it was. So it's going to be a load A, string pointer, Y. And then we're going to call the print character subroutine. Well, first, let's branch if equal, because if we just loaded a 0, I'm going to do this as a C style string, why not? So branch if equal, which should be branch if what was loaded into A was 0. Printster end, sure. And otherwise, we take that character that we just loaded into A and we call, we JSR printer, and then we just do my old standby of paranoid programming. Clear carry and branch carry clear to... Yeah. Just jump back to the last address. It's beautiful. And then JSR. So, let us look at how you write a string literal in here. Because it would be something like, you know, usually it's something like that, or something, and then blah, 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 blah. And then that's just like a byte command where it would put that string in memory wherever your assembling pointer is, and then you can reference it that way. But I don't know what this supports, so let me look. Let's just see really quick what this already makes me feel like I might have to do things this way, which if I have to, that's fine. I mean, they're probably not really going to have text in here, huh? Probably not. No. Alright, let's look at, do I still have the documentation open for this? The CA65 documentation. And we want let's see, wherever byte is, I'm sure it will be in the same area. Hey, look, they have an ASCII Z. There we go, exactly the way that I thought it would be. So, continuing to put everything at the end. And I can't write hello world because I haven't handled spaces because there isn't a space character in there. Which I can and will when I clean this up, but let's just make it hello for now. Hello string is dot ASCII Z. Don't ask me why I'm still writing everything in uppercase. I don't know. Hello. And then, in order to pass that to our print string function, we need to take that address and put it at the string pointer. And so, where is our current print char code? Right here. So instead of this, it will be something like, here's the question. I'll have to look at expressions because I need to break down the address into the high and low part, which I know how to do with some which I used to know how to do with some assembler that I am not currently using, and have no idea how to do it with this. Is anybody yelling at me? No. Yes, cool. So they do support this, which is kind of how I remember it working. So I believe it is just going to be like load A, and then the symbol, which was hello string, and then store A at, it's little endian, right? I think it's little endian. Yeah, 100%, yes. Store that at string pointer. Oh, I never incremented y in the print string. That would be important. Yes. Let's make sure we do that. That's important. Okay, anyway. So, we load the low byte of the hello string address, and we store it at the first byte of the string pointer, and then we load the high byte, and we store it in string pointer +1. Hopefully that works. And then we should be able to JSR print string. And let's watch this not work, but still cross my fingers, because hopefully this should print hello. Warning, suspicious address expression. What does that mean? 141. What don't you like about my addressing mode that I'm using? 141. Yeah, because that's not... I'm trying to do math. Damn you. Can I just do that? Would you prefer that? 161 illegal addressing mode. What? Well, what's 138? So that's these guys, right? Suspicious address expression. What? I mean, I clearly am not using this right, but does it need to be postfix? Nope. And it's still saying 161 it has some problem with, which is fascinating. Oh, wait. I don't know why that would be illegal addressing mode, but you need RTS, not JSR. 138 and 140 is just a syntax error now. Okay. And now we've got undefined symbols. All right. Probably because it's a one-pass thing, and it needs to be ahead of the thing that calls it, the thing that references it. Does that take care of that? No, it didn't. That's fascinating. But print char is defined right up here. It's right there. Wait, how did this get there? Oh, because it's the one for that. And same thing for this. Okay, why don't you like print char? Oh, because it's PRNT. That's why. PRNT, because I can't just write the whole thing. And I didn't define this character, this symbol. That would explain why it thinks I don't have it. Right, so I should just be able to place that there. And I still need to figure out how I use that friggin' low and high address thing. Yeah, those are the things that it doesn't like now. How I use them. How I use them, please. Like, do I need to put a space in there? Do you have examples for me? Yeah, it was PRNT versus print. I should have just looked at chat. That's all I would have needed to know. Okay, so now all I need to do is figure out this. Can I just do dot low byte and dot high byte? Will you let me do that? On 38. It expects this. Okay. I appreciate you telling me this. Nope. That didn't work. Does it want it this way? Nope, it's still saying suspicious address expression. Is it, again, is it because, like, this hasn't been... Is it because this isn't declared ahead of that? What if I move this declaration to the beginning? Put it ahead of the entry point. Because I can't really do that, can I? Because my entry point is at E1000, and that's important. Or wait, no, that's not important, because this is referenced by the vector, so even if it's like offset from that, it doesn't matter. It does not care. This is almost certainly not what the issue is, but yeah, still, suspicious address expression. I don't know, let's do some Googling. When in doubt, Google it out. CA65 low. What was that called? Low byte. So it's just saying it's suspicious, but I don't know what it means by that. I mean, it's just giving me a warning. I guess, I mean, that's the same thing it was giving me before. So I'm going to stick to using these operators because they're shorter. And it's not, it's just giving a warning. So, I mean, I suppose technically it is probably building. Even though I still don't know what it means by that. Let's clear those. Uh-huh. Okay, so not surprised it didn't work. But let me look at where it actually figure out where those values are set. So if I look at E1000, I should see, yeah, this is my string. You can't tell, but it's fairly obvious because stuff in the like 40 hex range is capital ASCII characters. So 48, 45, 4C, 4C, 4F, 00. That's our hello string. So, of course, our base address is E1000. So, somewhere along here we have, towards the end, so right here, this is our loop deal. So just above that actually is where, right, it's right here. This is where it is calling print string. So load a 00, load a E0. So I don't know what it's complaining about. That's correct. So I guess let's put a breakpoint at our print string, which is at E130. Sorry, make sure that is set for execute. Oh, or just recreate it entirely. E130 when it is executed. Excellent. Run NES reset. Okay. So right now, that's fine. Step over. Then we're going to load a... Ah, interesting. So maybe I have this addressing mode wrong. Oh, wait. Wait. Let me look at RAM. Let me look at RAM really quick. This is RAM. Yes. What? So this is our zero page. Zero page is the lowest memory addresses, and so that address, the string, the address of the string should be in here, 03 and 0. Or no, it should be 02 and 03. Maybe it's 03 and 04. Let's double check. Oh, I don't know why I set it to 03, but it would be, it's 03 and 04. One second, let me look at that. Let me look at this assembly again, because let me make sure it's writing into the right spot. No, yeah, 100%. Oh. That's probably why it's saying suspicious address. Because it's calculating it to not be a immediate. It's calculating it to be a zero-page address. That's why. That's why it's losing its mind. So, all we need to do is put a pound in front of those address calculation thingies, and I think we'll be okay. Yes. Yeah, there we go. Let us reload. Let us clear the debugger breakpoints. And close this just because. Yeah, close the debugger. Cool. And open it. And still didn't work, but I think we're getting closer. I think we're getting closer. What was that breakpoint again? Oh, wait. Stupid debugger. Ha! Ooh. Sorry for punching you. There you go. We did it. All right. 358. Let us get. Man, I like how chat has clearly... Narayan says, address expression is sus. That it was. That it was. It was trying to let me know. Yeah, Trey is always just a step ahead of me, and I'm not over there looking at chat. Thank you, Trey, for trying to help me. All right, that's it. I'm going to call it in that. I'm going to move this, move that over here, and then we're going to run it, and then I'm going to go to bed. Probably on the couch, because I imagine it's almost 2 a.m. My wife is certainly asleep, and more importantly, the baby is almost certainly asleep. So, to the couch it will be. Not as a punishment, as a just don't wake up the baby, please, or I'll murder you situation, which I fully understand. Yeah, all right, so this is already built, so yeah, because I wrote this nice little linker script, build script thingy. Also, calling it nice is awful over-flattering to it. It should just be this easy. Turn this off. Nope, that was already off. All right, follow the steps with me. You all know the words by now. Pop this bad boy out. Lord, don't let this be the time that the legs finally break off. How exiting on such a high and then breaking everything would not be the best. I could still step away from it with my head held high, but kind of a bit of a Pyrrhic victory. In the socket you go. I never did go look for that zip socket, did I? Whoops. Maybe for next time. Okay. And we program. Programming flash. Verifying flash. Succeeded. And then we pop it out. And then we pop it in. not broken. And in the slot it goes. And the tweezers go on it. Because this is what it says in the manual. This is how you use, this is the official way of using a carton in an NES. You've got to use a pair of red fine point tweezers. Okay. All right. FYI, I heard knocking on the door earlier. Really? Interesting. Because the door is open. It might have been knocking on the floor. I don't know. You're probably more attentive than I am. Thank you. All right. Good night. Oh, that feels good. Having done... This is my 8th stream, right? Only 7 of those have been work streams. So having done 6 streams of trying to figure out stuff, that feels nice. That feels good. This is as much as I can celebrate right now. I'm pooped. But that was honestly a lot of fun. And now I'm gonna get some sleep. And you guys should too, unless you're in, you know, some crazy different time zone. Thanks so much, guys, for tuning in and streaming me and just being cool. I really appreciate it. I won't try and be too sappy, but this feels nice, and it's cool to have had people hanging out with me, doing it, watching it, cheering me on. It's just cool. We live in a world where, you know, randos who are into this kind of whatever silly, niche, marginal thing can track it down and check it out, and that's just cool. Because this would be just as fun to do in my bedroom by myself, and has been for years, but having you guys watch, it's a handful of people, but having you guys tune in and check it out, and having the chat about it, I have to hope that you're all good people that are super cool, and so I'm just going to keep doing that, because you don't know, you're a bunch of randos, but you're at least chill enough to come here and check it out and cheer me on. So that's enough of that. I just appreciate it. And after doing a 4-hour stream, we're over 4 hours now. Feels good, man. All right. Good night, everybody. Thank you again for all of your help, because most of you were really quite helpful. All right. Shutting it down. See ya.